the future.
Oh, that's wonderful. So I know we're at the top of the hour. The panelists have agreed that they can stay longer, but and so we're going to talk a little bit about future Mars exploration, and then we'll get to more Q&A from the audience. But I just want to let folks know who did have somewhere to go that the panelists are going to stay. So let's move in. You mentioned the sampling. So Perseverance is collecting samples. So Neil, Lockheed's been a part of some previous sample return missions. And so can you talk a little bit about sample return missions and how you possibly could return samples from the Mars Perseverance rover?
Sure. So there's already RFIs in place for this next mission that you're talking about. It's going to be called Mars Sample Return. We recently completed a proposal for one of these RFIs to go off and build another aeroshell. This one, Mars 2020 aeroshell, was 4.5 meters in diameter. The next aeroshell for Mars Sample Return is going to be even bigger, believe it or not. It could be as big as 5 meters in diameter. So we were asked to propose this newer, bigger aeroshell. In addition, there's a new lander that's an even larger lander that's JPL will be responsible for. It's called the Sample Retriever Lander. And so this big lander has to get down to the surface, and its primary purpose is to go pick up the samples that Perseverance has left down on the surface. So the next mission to Mars will be close to where Perseverance is right now so that they can go pick up those samples. And then there will be additional missions that actually land a rocket down on the surface of Mars that could be used to take those tubes, stainless steel tubes that have samples from Perseverance, and fly those back to the US or back to the world, the Earth, so that we can see what's actually down there on Mars and see if there's any signs of life. But those are missions out in the future. This particular RFI we just proposed to would launch in 2026. So we're talking about 4 or 5 years out. And then the sample return mission is probably a year or two after that. So
great.
We're hoping to be part of all those. We love Mars, and we love going there whenever we have an opportunity.
We have that in common with Aerojet Rocketdyne. We love Mars too. So going to turn to George and just see, George, do you have any other additional thoughts on sample return missions? And then if not, what kind of planning is going on for future Mars robotic science missions?
Since Neil brought up the fact that there will be future missions that will need to go return these samples. We, Mars 2020, cannot lift off and come back home. And one thing that's very unique, I talked about the prior missions, and we kept building on prior missions and the knowledge. Each mission we've done has, taken the knowledge from prior ones and built on that. But this will be one of the first time where we've actually had hardware interfacing between 2 different missions launching in 2 very different opportunities. And so I want to illustrate kind of what that interface will be. So since I'm at home, I didn't have my usual props of my 3D printed sample tubes, but I realized that a little flashlight is about the same size as a sample tube. I even took my calipers to it, and it just so happens that this is roughly the same size and shape, even this little bulbous end of a sample tube. So we're carrying about 42 of these with us, and we'll be able to leave them on the surface. And so the future missions that we're talking about designing, we've already been working for the past several years creating what we call interface control documents. So basically agreements between our mission and future missions to be on are there any requirements we have to actually place on these tubes, and how we can keep the samples, keep sample integrity for when we eventually get them home? And what do those future missions, how do they need to be designed to actually pick these things up and put them in some sort of container to come home? And continuing our flashlight analogy, the actual sample itself, it turns out it's pretty close to the size of a AA battery, maybe one and a half AA batteries. And so that's what we're talking about. This is going to be the gold that we get home. And if you can go to chart number 21, I actually have a picture of the real sample tube. This is part of our caching system. This is during thermal vacuum testing of it. And what we're doing in this image, what is happening, we're testing, putting the tubes in and out of their storage silos that we have to carry. We're able to, once the sample is in the tube, we have to bring it inside the rover, seal it up with a hermetic seal, a cap, and then we have two choices. We can either hang on to it for a bit and wait until we want to drop it, or we could drop it right there. Most likely our plan is we're going to be putting them back in the silos where we pulled them out. And then once we get to a location on the surface where we want to place this set of samples to await the future missions, then we would start depositing them there. We call that the depot cache approach. So all these future missions that we're starting to look at is we're in the planning stages now. And a big component of that is doing it with our partners in the European Space Agency. So some of the elements that Neil talked about, the retrieval landing system, landing a rocket, we call it the Mars Ascent Vehicle, that would lift off this set of samples, would be provided by, we're looking for being provided by NASA. European Space Agency is interested in providing what we call the Fetch Rover, such that if Perseverance itself isn't able to deliver the samples to that lander, a Fetch Rover, a smaller thing that's specially designed to go and pick up these types of tubes and bring it back to the Mars Ascent Vehicle. And then once it gets off the surface, there needs to be a return orbiter. And that's the third component of this, sort of three major components. The sampling mission, that's us. A retrieval mission on the surface, get it off into Martian orbit, and then another mission that will rendezvous with that sample container that's in orbit around Mars and bring it home to Earth.
Wow, that's amazing. Thank you so much for sharing that and bringing your flashlight to explain it to us.
Oh, I got a new prop now. It's great.
Great. All right. So, Katie, as I mentioned earlier, I've got this great exploration rocket NASA does. It's the Space Launch System that wants to bring humans to Mars. So from your perspective, the science perspective, what needs to happen before humans go to Mars?
Well, I think going to Mars is kind of like planning a trip here on Earth. You don't go without having done a little bit of research about what the location is like and what the conditions are like, and perhaps what you need to bring with you and what you can get when you're there. And so in some ways, it's very similar to planning trips here, but in particular, we want to understand what kind of conditions our astronauts or Marstronauts would experience if they went to the surface of Mars. And we've been making progress on that question with previous missions as well. And in particular, one of the concerns that we have for astronauts when they're out in that space environment is radiation. And there's an instrument on the Curiosity rover called RAD, which has been measuring radiation since it was on its journey to Mars. And so we know a lot about from previous rovers. But with Perseverance, we have a weather station basically to understand pressure, temperature, humidity, dust in the atmosphere. And those are all very important pieces of information we would want to know if we were to send astronauts to Mars, to know what kind of environment they would be encountering and what kind of equipment they would need, how their spacesuits need to be built. And so our robotic explorers are doing some of that reconnaissance and data collection that can help enable planning for human exploration. Another thing we often think about is the in situ resources that Mars might have. that astronauts could take advantage of when they're on the surface and perhaps don't have to bring with them, because mass equals dollars in a lot of in a sense when it comes to missions like this. And so if there are ways we can take advantage of the resources that Mars has, we don't have to bring those things with us. So we think about things like understanding the climate cycle and understanding, water and where it is at the surface or subsurface, and ice and what conditions, what the weather's like, to affect things like where those resources might be. And so those are the kinds of things that we think about and we want to understand, and what the material properties are of even the soils and the rocks are on Mars, because those could all be different resources that get used by astronauts in situ on Mars. So I think those are some of the things that we think about, and that Perseverance in particular can contribute towards. And so each time we send a robotic explorer, we're making progress towards that goal of sending humans to Mars. And we can do that, fortunately, in a way that addresses interesting science questions for Mars about Mars's atmosphere today and the conditions on Mars, while also, in service to that goal of human exploration and advancing that part of our objective.
I love the sustainable approach that you all are really taking to exploration and taking it one step at a time. I think it's great, and I commend you for that. So before we get into the lightning round of questions, because we've got a lot coming at us, I wanted to ask Neil one thing about, he mentioned the Dragonfly that he's working on, which is going to send like a drone-like vehicle to Saturn's Titan moon. And so I wanted to know if you could talk about the lessons learned from the Mars 2020 Perseverance rover and the Mars 2020 program, and how you're applying that to the Dragonfly mission, Neil.
Sure. So we're always gathering lessons learned from the various programs that we work on. Started back, at least for these big Mars missions like MSL, Mars Science Laboratory, we had to build a very similar structure, identical structure, essentially. It was considered to be build to print. So back on the MSL program, we actually built 2 heat shields instead of just one. We needed a second heat shield to do environments on, and that heat shield became a spare, which when we got on contract for Mars 2020, that piece of hardware was provided as government furnished equipment for us to save money on the Mars 2020 program and use that heat shield in addition to the new back shell that we had to build. Well, as it turns out, the biggest risk on the program for the aeroshell was that heat shield that was now 10 years old survived the static test. It had to go through testing just like any other piece of flight hardware to prove that it was capable of going to Mars again. And as it turns out, that heat shield was not adequately built to survive the new environment that was being imposed on it by Mars 2020. And we had a failure at that point. So we had to go back and figure out, well, what happened to that first heat shield? It was the first heat shield of its kind of that size. So we learned a lot. We figured out what went wrong with that first heat shield, and we fixed it for Mars 2020. So it's all information that will be used on this new mission called Dragonfly. Turns out Dragonfly wants a 4.5 meter aeroshell as well. So it's very applicable to use everything we learned on Mars 2020 and MSL on this new heat shield. We learned a lot about how to improve our processes, how to test the hardware early so you know that there's no issues with the hardware. We developed some new test approaches using IR thermography to look for disbonds of the structure. We did some testing by applying a film to the surface of the heat shield during the static test so we can monitor strain levels as you're applying more and more load to that structure. So that we've got tons of lessons learned. We've got a big long list. I've got the same people working on Dragonfly that worked on Mars 2020. So
that's wonderful.
Yeah.
All right, so we're going to go into lightning round where we're going to try to ask as many questions as we can and answer them as quickly as we can. So Christopher asked, what's the launch system? So I'm going to go ahead and answer that one for you. It's ULA's Atlas V rocket. Ashley wants to know, you said it uses nuclear power. Is that the type that converts nuclear directly to electricity? George, do you want to take that one?
Yeah, we use what's called a radioisotope thermoelectric generator, and we use the exact same type that MSL used. And the basic technology has been used for U.S. space missions for decades, for 50 years. And in fact, Dragonfly, we use a similar system. And what it does is you have a small pellets of radioactive material, plutonium dioxide. It's a ceramic material that just heat. And we have several of those stacked up, and we have thermocouples wrapped around it. So it's a passive system. There's no moving parts. And those thermocouples directly convert that natural heat from radioactive decay into electricity. And for Perseverance, we get actually a twofer with the system. We don't, in addition to the electrical power, we also get the heat, which is what we need on the surface of Mars. So there is actually a fluid loop pumping through the rover to help transfer some of the waste heat from the RTG into the interior, what we call the warm electronics box, to keep the insides of Perseverance nice and warm. And that's what enables us to do what we need to do on the surface of Mars.
Awesome. And I'll also mention Aerojet Rocketdyne builds the nuclear power source for
That's right, you do.
the rover. So another Ashley wants to know, how long does it take to build a rocket? I think that's going to probably be best answered by the rocket provider, ULA, United Launch Alliance. So since we don't have them on this panel, I recommend if you go to their Twitter account and tweet them, I think it's at ULA Launch, they probably will answer that question for you. So next question from Joel. What opportunities might there be for citizen scientists to participate in the mission? Katie, is that something you want to tackle for us?
Yeah, we've thought about different opportunities, and there are some opportunities already to do Mars research and assist with Mars research, and so citizen science, I think, is a growing area. We don't have anything at the moment that we have planned, but we're thinking about it in terms of thinking about identifying interesting places in the landing ellipse, and perhaps opening that up and allowing our own community to take a look at the landing site and dig into the images, and perhaps help us identify interesting locations. So we don't have anything that I can say that we've confirmed that we're going to do, but we're thinking about it, and we'll be sure to let you all know if we are able to kick something off like that. That's a great idea.
That's awesome. All right, so next question, George, this might be one for you, for Mario. Why are the wheels covered?
Oh, from the picture. Actually, if you can put one of those pictures of the rover with the wheel coverings. One of the, we're searching for potential evidence of ancient Martian life, right? Well, the first thing you don't want to do is bring some sort of Earth life with you and have our science instruments basically detecting Earth life. So one of the key things all Mars missions have done, this is part of what we call planetary protection, is, and that's why when you see these spacecraft being put together, they're in clean rooms to keep any potential of Earth contaminants as few as possible off the rover. So since the wheels themselves are what's going to be touching the surface of Mars, we want to keep them as clean as possible right up to the last minute. Katie, is there anything else you want to add to that, or did I hit it?
No, I think you hit it. I mean, we take it very seriously, the cleanliness of the rover and the system, because we want to make sure that the samples we get back, and the things that we find in those samples are indigenous to Mars and not things we brought with us. And so we take that very seriously for this mission, particularly because of the sample return component. And so we've taken extra measures to keep the spacecraft clean and to protect what we call the sample intimate hardware, the parts of the rover that are going to interact directly with the samples. And so that's the wheel coverings are one example of ways that we try to keep the rover and the spacecraft clean as we're putting it all together and getting it ready for launch.
So the tires are a big question. So Patrick wants to know, how are the tires different on Perseverance opposed to Curiosity?
I can take that. So as some of you may have noticed, Curiosity is starting to get some holes in its tires. And this was not completely expected. And we, of course, we're doing a lot of things very heritage, trying to do as much build to print as we can. But we even though the wheels are still, even though the part of the wheels have some holes in them, they're still perfectly capable and functioning. Curiosity can keep doing its mission for a long time. But we certainly thought that we'd like to maybe make some improvements. So what we did a test with various different types of sizes, size modifications to the wheels, also changes to the treads, because it actually the tread shape on Curiosity is sort of a jagged chevron pattern. Turns out that actually is part of what was contributing to some of the holes. As we would roll across a particular rock, it would create greater forces there than it was designed. Oh yeah, thank you for putting that up. You can see on the Curiosity wheel that jagged, what we call the grouser. So for Perseverance, what we've done is we made the skin, oh, perfect. You'll see the skin of the wheel, it's still all the same material. It's all hogged out of a single chunk of aluminum, but it's slightly thicker, so it's more robust. But once you do that, you're adding weight, right? So how can you potentially offset that? So we've made the wheels slightly narrower. We also made them slightly larger in diameter, and then we changed the tread pattern there. We now have sort of a nice curvy wave sign. And it turns out that these wheels are actually much more robust. We have a test set up at the Mars yard at Jet Propulsion Lab, where we've run these wheels around and around and around, tens and tens and tens of kilometers, and they are just scuffed. So they're going to be quite durable for us. And on top of that, the new grousers actually give us a little bit better traction, so that we have a little bit more margin and a little bit more robust capability for going up or down slopes and sandy terrain.
Oh, that's awesome. All right, so we're gonna move on to our next question. How, if at all, is COVID-19 threatening the July launch? And this is coming from Julie. And then what preparation activities, if any, have been moved to a virtual environment?
I addressed that a little bit earlier, but I'll repeat. Certainly the COVID-19 situation, like many people around the world, had to adjust to the way we do work, particularly for our folks who are doing the mission critical work. The majority of our team has successfully transitioned to remote teleworking. Timing helped in this regard. Most of our hardware was completed and already at the Cape, and had already been transported there. So with the small teams that we still do need to have working on the hands-on critical hardware, like I said, we've kept the first priority is the safety of the team, as well as the community they're in. So we've been able to work with occupational health officials at our NASA centers, and taking guidance from Centers for Disease Control, as well as the local centers there at Jet Propulsion Lab in Kennedy, and been able to put in place practices so that our team can operate safely. And so far, we've been very successful. We are still on target for launch, so still making the milestones.
Awesome. Sunny wants to know, Katie, will Perseverance provide data to students, community, or universities for research?
Yeah, so all of the rover data goes out almost as soon as it gets back, and we have agreements to make sure that the rover data that we collect is available and accessible by the public. And so, for instance, the images that the rover takes, those are again available almost immediately once they come down. In terms of some of the other data sets that we have, usually they take a little bit of processing and preparation, but then they get posted, particularly on it's the PDS is what it's called. It's a data repository and we have an agreement to post the data there to the PDS. It's usually about kind of a 3 to 6 month time frame from the time that we get it. It's packaged with the proper files and explanation and put on the PDS, this data repository. And so yes, we make that data available to the public, and we encourage and are excited for those outside of the Rover team to dig into that data and present science results and interpretations from that data.
Awesome. All right, I know we have just a little bit of time left. So Saita wants to know, should NASA collaborate with other international space agencies for Mars exploration like it does with the International Space Station?
I'll take that one. We absolutely do. In the game of space, we all can accomplish more if we're working together. Perseverance itself certainly has international contributions. If you can go to which one? There's the chart, the rover showing the instruments. Yeah, you'll see there's a couple of flags here. We have several contributions. Spain is contributing quite a few things. One is the weather station that Katie spoke about. Spain is also contributing the high gain antenna. So this is one of the main ways we communicate with the rover. They also provided that for Curiosity. France is contributing a large component of the SuperCam instrument. It's led by Los Alamos National Labs here in the US, but about half of it, some of the components are provided by France. We also have Norway. It's providing a brand new instrument we've never had on Mars. It's a ground penetrating radar. So this is another total new dimension. We're actually going to be able to, we've had orbital radars looking beneath the surface a bit, but this is the first time we'll be able to do it from on the surface. And lastly, Italy is contributing. It's not an active science instrument on our mission, but for future, they put a laser retroreflector. We put these on several, I think the InSight mission also had one, such that if in the future there could be a mission that has a laser ranging instrument, that we will be able to do some even better science in that laser ranging with these retroreflectors. And I also mentioned earlier about how for going forward with our future sample return activities, we are definitely working very, very closely with the European Space Agency to try to make that a joint and collaborative campaign.
Wow. All right, we got 2 minutes left. So Neil, 30 seconds or less. Tasha wants to know, is there a reason why the heat shield has a certain block configuration?
Yes, what you're actually seeing there is individual tiles. Just due to its size, you cannot machine a piece of TPS big enough to fit on the entire heat shield. So it's broken up into individual tiles. So you probably saw some of the lines in that image. Probably going to bring it up. So each one has its own reason for being the shape it is. You can see some highly triangular shaped tiles there that are there due to the heating at that particular point on the heat shield. So that's the reason, and there's reasons. That's good enough.
All right, so our last 1 minute together. Tell me what you're most excited about for this mission, or what inspired you to get into Mars exploration. So Neil, I'll start with you.
Okay, well, it goes all the way back to childhood. My father was very enthused about space, and I initially got into SD's rockets when I was a very young child. We built a Mars lander, believe it or not. If you look at some of the concepts for Mars landers for people to go to Mars, it's very similar to that. You know, that was probably that we built probably 50 years ago, believe it or not. So that got me kind of enthused about space. The Viking landers that landed in 1976, I was very excited about. Martin Marietta, it was where my parents lived. I really wanted to go to work for Lockheed or Martin Marietta at the time. And I finally got a job in 1984 working for them. Now it's Lockheed Martin, but that's what got me excited.
Awesome. I'm glad you were able to get on with them in 1984. All right. So Katie, what are you most looking forward to, or why did you get into Mars exploration?
I'm most excited to look for biosignatures in that delta. That's the big thing that I'm looking forward to. In terms of how I got interested, I thought I wanted to do astronomy, and I was really interested in stars and things that were very far away. And I had the great fortune of taking a geology class in college, and I realized, wow, here I am with my eyes focused outward, and I don't know anything about the planet that I'm actually on right now. And I think that had a big effect in helping me focus on planetary geology and trying to take what we know and understand about our planet here on Earth and use that to inform what we know about other planets. And that led me directly to Mars, which in some ways is very Earth-like, in other ways not at all Earth-like. And so for me, Mars is a great place to work and a way to translate the or to combine something that we know and understand very well with something that we've never done before, and exploration of a place we've never been before. So to me, that's this perfect combination of the known and the unknown. And it's why I'm so excited to explore Mars, and I'm very excited for what we'll find with Perseverance.
How cool is that you get to say I work on Mars? That is,
I know, it's pretty amazing.
That's awesome. All right, George, take us home.
Yeah, I kind of echo what Katie said. I'm most excited about this. There's so much going on, as I said, lots of neat technology. Science instruments are awesome. We're going to get great science. But I'm just generally excited about the concept of exploring a new place on the surface of Mars. A different type of terrain than we've seen, at least what we can tell from orbit. I remember I was fortunate enough to be in the at JPL and in some of the with the science team when we got some of the first images from Spirit and Opportunity, and seeing how diverse those two landing sites were. And then with Curiosity, landing in that environment, and then being able to look at that terrain and see the crater wall off in the distance, and then Mount Sharp just right there begging to be climbed. So I'm super excited about seeing that, some of those first pictures when we sat down in Jezero crater and that delta, being able to go about that new terrain, heading across it, and then maybe even up and over the crater rim. I think that's what I'm most excited about, getting the samples, bringing them home, and really beginning humanity's first round trip to Mars with these samples.
Thank you. I want to thank all of our panelists and thank Explore Mars for putting on this wonderful event. Hopefully everybody has enjoyed it. I think it was an outstanding event. I know I learned a lot today. So thank you very much. And if you haven't checked out the Perseverance Twitter account, I recommend. It's tweeting about what it's up to in the first person. So it's a lot of fun. And then JPL has a Twitter account, NASA has a Twitter account, Aerojet Rocketdyne has a Twitter account, Lockheed Martin as well. All of us have social media accounts, so you can follow along and prepare for the launch in July, and then hopefully the landing on February in 2021. Thank you all, and I'll turn it back over to Chris Carberry.
Let's see, 1 second. There I am. Thank you, Mary. Thank you, panelists. That was spectacular. I don't have much else to say, but thank you, everybody, for coming on. We will be announcing our next week's session very soon. In the upcoming weeks, we'll have sessions on the 30th anniversary of the Hubble Space Telescope, as well as a mission architecture, Mars, Humans to Mars mission architecture panel coming up, and quite a few other topics. So stay tuned. We have a lot of great webinars coming up. So once again, thank you to everybody who came on and to our panelists. Have a good day. Hello, I'm Chris Carberry, CEO of Explore Mars. Welcome to the first Humans to Mars webinar, Life on Mars, What Are the Implications? I hope everybody is healthy and safe in these strange days. Like many other organizations, we're launching numerous online programs to educate, entertain, and inform people interested in Mars explorations. Thanks to all of you who were able to attend our first weekly virtual Drinks with Explorer Mars. A fun time was had by all, and I hope you'll join us again next Tuesday. We're going to be doing them every Tuesday evening at 8 o'clock Eastern Daylight Time. Also, in partnership with our president, Janet Ivory, we're also hosting Janet Planet's online astronaut academy weekdays at 10 o'clock a.m. Eastern Daylight Time. Students from around the world are taking part in this spectacular event, so you should check it out. And for today's panel, which is the first of the ongoing series of weekly webinars that will be running and probably beyond the Humans to Mars Summit, but certainly up until the Humans to Mars Summit that's taking place on August 31st to September 1st at the National Academy of Sciences building. Of course, you can find information on that at exploremars.org. Our next webinar will take place on Thursday, April 9th at 4 p.m. Eastern Daylight Time, and will focus on managing isolation in space and on Earth during our current crisis. The panel will be moderated by television news personality Sonia Gavankar, and we'll have special guest Scott Kelly, former NASA astronaut and author of Endurance, Dr. Susan Ip Jewell, president and co-founder of the Mars Academy, and John Hanasek, CEO and co-founder of Avatar Medic. Should be a great and timely panel. I'd also like to thank a few of our sponsors and partners of the upcoming Humans to Mars Summit, including Aerojet Rocketdyne, Lockheed Martin, Northrop Grumman, ULA, the National Institute of Aerospace, and the Science and Entertainment Exchange, and many others, all of whom will be highlighted frequently throughout this webinar series. Now, without any further rambling by me, I would like to introduce our moderator extraordinaire, the host of Planetary Radio, Matt Kaplan. Matt, welcome and thanks for leading our fascinating discussion today.
Oh, it is such an honor and a pleasure. Thank you very much, Chris. And Chris, I don't know if you mentioned, you are the founder and CEO of Explore Mars, which is the parent, the guiding hand for this event today. Explore Mars with the Humans to Mars Summit every year. That I so look forward to, and I sure look forward to the return of that wonderful gathering in Washington, D.C. But since we are all faced with these hopefully quite temporary necessities of making life go on from home, we are absolutely delighted. We are thrilled that all of you could join us for this first outing. I am with the Planetary Society, where I have hosted and produced Planetary Radio for the last 20 years. But we have had a wonderful time collaborating with our sister organization, Explore Mars, for a good part of that period. And are delighted to continue that today. And I bring you greetings and regards from our CEO, Bill Nye the Science Guy. Having said that, we should jump in because we have a lot to cover. I mean, it's as big as the red planet, our discussion today, and what we may find there. Let me set the stage for today's conversation with a hypothetical. We've jumped forward to 2024. A rover named Perseverance, that we'll be talking more about momentarily, has been rolling across Mars for 3 years. Another visitor from Earth, a more recent arrival, named Rosalind Franklin, has been pulling up samples from below the surface of Mars. NASA and the European Space Agency have just announced a joint press conference that is going to reveal images and other data indicating that we just may have found strong evidence of life. Will this news, as my boss Bill Nye likes to say, change everything? What do we do next, and how will it affect plans to send men and women to Mars? But I'm getting ahead of myself. So hold that thought for now as we meet the two very distinguished guests that will be joining me here. You can see them already, I hope, on your screens. I really can't think of anyone else I would rather have on board to talk about this topic, beginning with Dr. Penelope Boston. She is the Senior Advisor for Science Integration at NASA Ames Research Center in Silicon Valley. And Penny's personal expertise is the geomicrobiology of extreme Earth environments, especially caves and mines, and astrobiology. As a lifelong human space exploration advocate, she co-founded the Case for Mars conferences in the 1980s and 1990s. That makes her a founding member of the Mars Underground as well. She's a member of Explore Mars. She looks pretty great in a fake spacesuit. She earned her PhD in microbiology at the University of Colorado Boulder. She was till recently the director of the NASA Astrobiology Institute based at Ames, and is a former professor and chair of the Department of Earth and Environmental Science at the New Mexico Institute for Mining and Technology. Also, the former associate director of the National Cave and Karst Research Institute. Welcome, Penny.
Thank you. Great to be here.
Dr. Jim Green is the NASA chief scientist. He received his PhD in space physics from the University of Iowa in 1979 and has worked for NASA ever since. That included 12 years as the director of the Planetary Science Division at NASA headquarters. Under his leadership, more than a dozen planetary missions were successfully executed, including the Curiosity rover and InSight lander, both of which are still quite active and delivering great science on Mars. Jim is NASA's representative on the COSPAR Planetary Protection Panel, where planetary protection guidelines are created and agreed to internationally. COSPAR, that's the Committee on Space Research. In 1915, you're not that old, Jim. In 2015, Jim coordinated NASA's involvement in one of my favorite movies, The Martian. Talk about infecting a planet. By the way, he also hosts the excellent NASA podcast called Gravity Assist. Welcome, Jim.
Thank you very much, Matt. I'm delighted to be here.
So let's back up a little bit and talk about the current status of exploration on Mars now and what's going to be happening there, well, in less than a year now with the arrival of this new rover. Tell us, what's the status of Perseverance?
Well, Matt, Perseverance is actually moving forward. It's all down at the Cape. And in fact, the radioisotope power system is already connected. It's checked out in many ways. It still has a number of things to do yet, but we're making great progress. So it is on track for a July 17th open window for us to be able to launch. And that's when that highway opens up for the next 3 weeks that can get us to Mars.
This is like almost everything NASA sends to around the solar system nowadays, an international effort, right?
It is, and indeed. And in fact, if you had my little graphic that shows Perseverance, this particular rover has got a fabulous set of instruments where we have participation from Spain on a weather system. We have Norway having a ground penetrating radar. We have the French working with us on some really great camera and laser systems. And we have an Italian retroreflector. But the whole point of this particular mission is really at the end of the arm. This is where we have high resolution images that we want to be able to really look at the rock record and then make decisions in terms of creating cores. It's got a core at the very end of it. And I have an example of one that I can show everyone what these cores look like. They're like a piece of chalk in size, or for those that are young enough that don't really understand what chalks and chalkboards were all about in their education, like a Crayola crayon, one of the large sizes. Once those cores are made, they're stuck indeed into an aluminum sleeve and then dropped on the surface for then later pick up and bring back. So by the end of that decade, the 2020s, we hope to be able to have these samples back in our BioLevel 4 facility and begin the process of really looking through them to determine their viability and allowing scientists to get access to them for further research. So we're doing great.
So, and even though she resembles her sister on Mars, Curiosity, You've given at least a couple of examples in that image, and with those cores especially, of the new capabilities that Perseverance is bringing to the red planet. Pretty powerful machine, isn't it?
Oh, it absolutely is. And the rock record is so important to us. You know, we know that Mars was a blue planet early on in its history. It went through rapid climate change. It was a blue planet during the time we know Earth had life started on it. And so maybe life started on Mars too. And so we're really quite excited about going there and interrogating that, being able to bring back those samples and look at them. You know, for all the minerals we have here on Earth, there are hundreds of minerals for which life is such a key part of that create those minerals. And so if we can find the right set of information, indeed that press conference you talked about would be really lively.
So sample return, you know, I often refer to it as the holy grail of robotic exploration of Mars, and could be for other places as well. I know you've got a slide about that as well.
Yes, I do. If we can bring that up. This was how we envision right now working with our international community to be able to get those samples back, and it all requires NASA landing a Mars ascent vehicle. This is shown on the surface already in this diagram to the left. We then have fetch rovers that pick up those samples that we laid on the ground and deliver those. That's in the bottom middle. And then on the right, we launch off of Mars those samples in a container, and then that container goes into orbit, for which then an ESA satellite will come down using ion propulsion into low Mars orbit, pick those samples up, and then bring them back to Earth. So it's indeed a multinational effort, and the planning is going real well.
Penny, you're a longtime Martian. What's it going to mean to scientists like you to get those samples back here and into our nice big labs on Earth?
Well, you know, as you say, Matt, it's been a holy grail for many decades, and pretty much my whole career. I'm sure that's true for a lot of us. And the opportunity to actually get our lab facilities here on Earth to bring all of their power to bear on samples is a new step, really, in marching forward to be able to analyze Mars materials. The missions that we've had so far and the ones to come are magnificent. But, you know, there's only a certain amount that you can smash onto a spacecraft and a lander and a rover before you run out of power and mass and all of that. And so the ability to do these really in detail studies of the geochemistry, the mineralogy, the foundational bedrock materials, perhaps even some of the fine materials on Mars will give us insights into the climate history of that planet, which is very important to our understanding of climate in general on our own planet and beyond, and also potentially allow us to look at organic materials and various other things that may be significant for the potential history of any life that may have arisen on Mars.
Jim, I want to go back to you. I gave short shrift to all of the success we've already seen on Mars with 2 active spacecraft on the surface and that flotilla on orbit above the planet. Where are we in what we've learned? I mean, we found the water. Are we still following it? And what else have we found?
That's a really great question, in the sense that, you know, there's more to it than just following the water. You know, we've seen evidence of water all over the place on Mars. That's clear. We've seen what we call reoccurring slope lineae, where water may actually be pouring down the sides of craters in a seasonal way. This is during a time period, as you can see in this slide, during indeed that summer, where the sunlight shines on the crater walls, perhaps sublimates a water plug that's sitting in, holding back water in an aquifer, and then that water pours out and runs down the slopes. We've measured that. We know it's water. Now, some of these actually may be drifts of dust and therefore producing some discoloration, but there's so much of it, and there's so many places where it's occurring. You know, we're pretty convinced that that indeed there is a significant amount of water locked inside the planet. Now, in addition to that, Mars seems to be emitting what we would call traces of life gases, you know, like methane and like oxygen.
I'm knocking on wood.
Yeah, right. And indeed, although those things can be generated abiotically, you know, for the methane, we've been observing methane from telescopes on Earth since the early 2000s. But now with Curiosity making those measurements directly over and over again, we do see that seasonal bloom for which what we call this rush of methane coming out, although it's still a trace gas, you know, parts per billion we're talking about. And that is coming from underneath the surface. Now that could be generated abiotically. It requires water, requires certain minerals and a heat source like magma, or it could be old methane from old life in the past that is also been trapped over time and is being released. Or indeed, it could be an indication of life there today in the aquifers is what we would think. So those trace gases now are extremely important. We're making fabulous measurement of those.
And oxygen you mentioned as well. And I know that there have been, both for methane and oxygen, there have been some conflicting data, hasn't there, depending on the observer?
Yeah, indeed. The oxygen observations that we just released over the last several months is a long-term trend. It's about 5 years worth of observations, and it's a surprising trend. You know, as the planet goes through its seasonal cycle, we expect during the winter, because it's so cold, that a lot of the atmospheric gases, in particular the trace gases, will collapse down into the surface. And then as it warms up, it actually then releases those. And what we're finding is an excess of oxygen during certain times. And then at other times, we see that the oxygen actually is being removed. So this has really caused quite a puzzle. We've had many scientists really working, trying to figure out what are the abiotic, in other words, the non-biological reasons that this is happening. And we really haven't come up with a good explanation. So the oxygen observations are really one we want to stay abreast of and see what Curiosity is going to find in the future.
Penny, have we seen evidence other than what Jim has just talked about that could indicate biological activity, or at least past biological activity up there?
Well, you know, so far we haven't had the opportunity to closely examine materials, getting back to our previous discussion about sample return. But what we have been able to do, of course, is hook up what we understand about extreme environments on Earth and try to tease out the parts of those environments that are relevant to Mars. It's pretty clear we have nowhere on Earth that is just like Mars. It's a very, very challenging environment. But we have challenging environments on Earth that have components that really go into that Mars picture. And so microorganisms in their vast diversity, their unbelievable diversity on this planet, have adapted to, you know, a wild variety of conditions. Many of them are the conditions that we see in the Mars surface, and particularly, of course, from my point of view as someone very interested in the subsurface, both near and deep subsurface, where there is more protection from some of the nasty things that you get on the Mars surface. So I think that the importance of the gases that Jim has just been articulating is really because the atmosphere of a planet is its breath, essentially, and the breath of life on Earth is very, very clear. We have a very complicated atmospheric spectrum, which is the sum total of all of the complex gases that life on our planet puts out. When we're looking at a planet like Mars, if we're looking at life that has been not as globally as it is here on Earth for a long time, that is something of a relict biosphere, then we would expect to see a much more subdued signal. But the fact that there is this oxygen variability and the fact that we see these traces of methane are very exciting, because what that might say about life is that if it exists in the subsurface, there's a certain leak rate, just like we have with spacesuits and spacecraft and Earth itself, and that we may be catching little whiffs of what's going on underneath. In any case, whether or not it's biology or it's non-biology, when you have a life-bearing solar system like ours, in my view, every planet matters to understanding that life, even if that life only occurs on one planet. And of course, we certainly hope it occurs on Mars or has occurred on Mars, as well as other places in the solar system.
Hear, hear. Penny, you have spent a good part of your life going to places most of us would not want to go, looking for how life has found a way to survive. One of those more milder locations, I remember being with you at Carlsbad Caverns, and you pointed to a spot on the wall and you said, "You see that? That's life eating copper." So it does sure look like the enormous variety of extremophiles that we find on our planet. It's got to give you some encouragement, right?
Oh, very much. And, you know, even though I'm a Mars fan for my entire life, of course, I have an eye on the other potential habitats. And I think that the fact that we have organisms that appear to be able to tolerate almost everything, including high radiation, and organisms that have been retrieved from, you know, space exposure and complete desiccation and living amongst metals that we find toxic, but they're busy using inorganic chemistry to make those into energy sources, makes me really understand the sweep of what our type of life, meaning organic carbon in a water matrix, is capable of. It's really quite extraordinary.
Life as we know it.
Yeah, life as we know it. And of course, you know, many of us consider life as we don't know it. And that life as we don't know it extends to other ways of making life, even out of organic carbon. So there are people thinking about other alternative sets of chemistry that might work on other planets. But from the point of view of Mars, my conviction is that we're really looking for carbon-based life in a water matrix, because Mars is not all that different from Earth. And certainly, as Jim pointed out, early in its history, it was much more similar. And so that you know, early childhood of our rocky terrestrial planets together seems to me very significant. And even Venus in its current state, which is quite inhospitable to life as we understand it, but its early history may have also, you know, shared in habitable zones. So, you know, it's not just Mars alone that is compelling, but really Mars as this beautiful red jewel within this entire spectrum, this entire crown of jewels that we have in our solar system, and what they offer for life.
Have your studies and what we've learned from others in looking for biosignatures, that key term, has it led you to the point where you think that if we had life staring us in the face, we would recognize it?
Well, yes, maybe. The slide that was just put up shows a variety, and this, of course, is from my own work. All of these colorful and drippy, gooey things that you see are all examples of microbes, as tiny as they are, but making major changes in the rock and mineral environments that they live in. So the orange stuff that you see that looks sort of like a pizza or the surface of Io, that's all rock breakdown material that's been chewed through by organisms that use manganese and iron rather than, you know, eating hamburgers for lunch. They eat rock, and they use those minerals, and then they poop out, so to speak, all of this fluffy stuff. And so they're major geological agents on Earth, but it shows that they can make their living off a geological source You can see the screaming blue patch that one of my French colleagues is standing by, sort of in the middle lower part of the screen. And you can see an example of the same process. You were talking, Matt, about the copper material that I showed you. These are organisms all over the world that are different, but they're different and very unrelated, but they still are able to do the same thing. And so that makes me even more excited because it doesn't have to be the same organisms. It's finding a pathway of organisms in different places that can use the same energy sources. And so to me, that seems like an encouraging sign for extraterrestrial life.
Hey, if you've just joined us as we hit very close to the half-hour mark, this is the Explore Mars Life on Mars webinar, the first of a series sponsored by Explore Mars. And you just heard from Penny Boston. And I'm going to go back to Jim Green, the NASA chief scientist now. Jim, I want to jump back now to that hypothetical that I posed at the outset. That press conference, which you would very likely be a part of. I hope you're still on the job in 2024. You've got big news for us.
Right.
What's this going to mean if indeed we find evidence better than we've gotten in the past? I'm thinking of a certain meteorite, ALH 84001, that seems hard to argue with, that maybe we have found at least evidence of past life on Mars. What's that going to mean to us here on Earth?
Well, let me just mention, of course, there is an important aspect of thinking about that future when we start that announcement, and that really boils down to looking at what's happened in the past, by analogies. The ALH 84001 is a good one in the sense that, we would organize that press conference. On that press conference, we would have the scientists that are announcing the discovery, but also scientists that are a little skeptical. And so that announcement then would go out to the public, and then there would be a period where the community of scientists would really dig into the results. Perhaps if we return samples soon after that, they would then be able to have those in the laboratory, et cetera, and really tease it out, and then public reaction. And then an education has to go on to everyone in terms of the context of what this means. But if we just take that supposition that indeed in the long run it proves to be true, and we have found that second genesis and it is on Mars, what does that mean? And here by analogy, I think we have to look at perhaps several. One comes to mind is what Copernicus did. At the time Copernicus was coming out with the theory that the planets went around the sun and not everything went around the Earth, it changed the world view. Everyone mentally had to now rearrange their thoughts about their place in the solar system and the universe. And it had a profound effect. People thought, well, we are the center of the universe because everything goes around us. And now they go around the sun, just like the other planets. And then to them, that means, well, maybe there are other societies like us on other planets. This was a really profound change. I think, indeed, we're going to have to come to grips with that. Many people, because of our literature and our movies, are all set to accept that there's a second genesis out there. And in fact, many scientists, and that would include me, think it's almost inconceivable that there isn't some sort of life out not only in the solar system, but certainly on other planets. And so our worldview then once again will have to change. And I think it will change many different things. The results of finding microbes might be as revolutionary as cracking DNA. The concept of what's come out of microbiology, which is only a handful of decades old, has just been phenomenal. And that is awaiting us with this kind of discovery if we do indeed find microbial life on Mars, I think.
Penny, what would this mean to you and your colleagues, this announcement and the provision of this data?
Well, I spent my entire life doing this, and so have many of my colleagues. So I have dreamed about that happening in my lifetime. I hope it does. I'm trying to stay as healthy as possible to get the maximum chance. And, you know, the minute we got any kind of indication that there might be extant life or even extinct life, okay, because I also do paleomicrobiology and I'm interested in the entire deep history of planets with life. The entire community would go into a frenzy of trying to test whatever features this potential life would have. And so there would be an enormous flourishing, maybe in directions that we're already pursuing, maybe in new directions. It depends on what those results would find. And then I would throw one heck of a big party.
I'd like to attend that.
Please invite me.
I will.
We should get into the topic that maybe our sponsors here at Explore Mars are most interested in. After all, they are the humans to Mars people. And that is what the possibility, evidence for not just past, but possibly existing life on Mars, stuff that's still kicking up its heels there today, would mean for sending humans there. Jim, you were a big contributor to that movie, The Martian.
Yes.
It would not be a good idea for us to head there and plant poop potatoes, would it?
No, actually, Curiosity has found the nitrogen, oxygen, carbon, phosphorus, and sulfur on Mars, all the right stuff. The soils are moist, and indeed, there's nitrates in the soils. Now, where Curiosity is sitting turns out to have alkaline soils, not acidic. So what would grow better here would be beans and asparagus. And I don't know about you, but if I had to eat 2 or 3 years worth of asparagus, I'd just take my helmet off and walk outside. But I'm assuming I could do the potatoes. I'm assuming we all are assuming there'll be more acidic soils too elsewhere. And so indeed, the analogies between Mars soils and Earth soils is really strong. And that's really quite important. If we found evidence for current life, that current life has to be below the surface. We haven't found evidence of life on the surface. And for human exploration, I think we'd have to talk about how we're going to share Mars. And I think we can share Mars. There are many approaches, unlike the Martian, where the concept was you land Ares 1, and the next time it's Ares 2, Ares 3, Ares 4. We would plan to go to one particular area, you know, perhaps 150 or 200 kilometer area called an exploration zone, where we land in one part, live in another part, and then have the ability, mobility, to go around and perform a whole variety of scientific experiments, but really confine ourselves to that part of Mars. And in so doing, then it gives us a wonderful opportunity, perhaps over several decades of continuing to go there and continuing to build and develop things at that site, an opportunity to really learn the deep, and obtain a deep understanding of what Mars is all about. And then we can take it to the next step with that kind of knowledge. So I'm all for sharing Mars. Now, you may know that many scientists, particularly Carl Sagan, thought that if we found microbes on Mars, we need to leave Mars alone and go to another body in the solar system. But I think because life also has to evolve over time, the evolution of that life is going to be completely different than ours. And that gives us, I think, an opportunity to coexist. And those are some of the new ideas that are coming out now.
Annie, what's your view about all this? I mean, I think you want to see boots on Mars as well, but
I'd like to see my boots on Mars, actually.
Me too.
But I'm going to be too old, I'm afraid. But you know, it's something I've wrestled with my entire career, because I have this desire for exploration, for our species to go beyond to other bodies in our solar system, and who knows, someday even out of our solar system in some number of hundreds of years. But at the same time, of course, I'm very very aware of the deep ecology aspects of another biosphere. And this applies to Mars or any other biosphere that we may find in our solar system. And that is, how do we study it? How do we perhaps cohabit with it, as Jim points out, without doing damage to it, and in turn, without doing damage to us? I think that many years ago, probably 25, when I first started writing about the Mars subsurface as being the best place to look for life on Mars, it was not taken very seriously. We knew a lot less about the planet at that time, but we've plugged along on that theme, and I think it's become manifest that that is the place, as Jim says, where we would have the highest chance of finding subsurface life, even if Mars once was covered in life at the surface. That the subsurface, in many cases, particularly even on Earth, is a refugium, a refuge for organisms when circumstances change on the surface. We see this in microorganisms and macroorganisms. So there are caves with fish and invertebrates that have been separated for 20 million years from the surface and things of that sort. So I think that the expectation that I have is that any Mars life is going to be quite deep. And that helps us with this conundrum, because as long as we don't contaminate aquifers, as we're trying to get resources for human use, then the surface Mars environment is very harsh. And while I wouldn't call it entirely self-sterilizing, it will do a lot to reduce the plume of biological contaminants within some distance from a human colony. And then, of course, if we want to study things like the slope lineae, these trickles of water, briny water that Jim mentioned early on in our discussion, those are juicy targets, literally and figuratively. We can't wait to get our hands on them, but our hands will not be our hands. Our hands will hopefully be sterilizable robotic sampling devices that we'll be able to send out and bring those samples back for analysis. So there are ways to do this. And, you know, we're living through it now with this pandemic that we're all experiencing. How do we separate our activities from, in this case, a pathogen, but in the case of humans on Mars, how do we separate ourselves from potential organisms that are the Martians and keep all of us safe? And so all of these real world things are being worked out in real time. And as you know, Jim mentioned, or you mentioned that Jim is on the COSPAR panel, that dates back to the 1950s and the early part of the space age. So it's not like we just discovered that, oh, gee, there might be a problem. Many of us have served on panels and workshops, and we're writing about it all the time. So it's very, very much foremost in our minds about how to do this safely. I think we can do it. I hope I'm not being naive.
Jim, I'm really glad that Penny brought us back to that COSPAR committee that where you are the planetary protection representative from NASA, from the United States. How is this being considered by the international community? These questions of protecting Mars, but also wanting to go there and have humans explore.
Well, indeed, COSPAR over the years has looked at each and every one of the bodies in the solar system that were being considered by space agencies to go to. And indeed, early on, we didn't know much about the moon in terms of whether there would be pathogens there. And so consequently, those guidelines that came from the COSPAR committee that the international community signed up to meant that we, for a NASA perspective, wanted to implement a quarantine system. So when samples came back from Apollo 11, you know, the astronauts went into quarantine and the samples went into quarantine. And then we went through our processes of indeed interrogating those and understanding what they are, what we had, whether there were pathogens, etc., watching the astronauts over a period of time. And then finally, recognize that indeed we could have uncontained sample return from Mars. We didn't need to go through the quarantine process. And so then that means the guidelines were revised. So the committee indeed takes it very seriously that as we learn new things about each of the bodies that the space agencies are planning to go to, we take that into account to modify those guidelines. And that's been working really well. In fact, just recently, we took a good look at Phobos, and we recognized that Phobos, indeed, one of the moons of Mars, we could actually back off some of the more stringent guidelines on returning samples. And so we've categorized Phobos as a location where we can have unrestricted Earth return of those samples. And the Japanese JAXA mission is being planned to go there and has many international connections and components to it. But that required for us to bring all the knowledge we knew about Phobos forward and not consider it like Mars in a category of more restriction. And so we're going to continue to do that. And that process is working well.
We are rapidly approaching the point in this program where we're going to be turning to your questions. And I do see that lots of you are submitting them. They are being consolidated for us by the president of Explore Mars, Janet Ivey, of Janet's Planet. And by the way, I want to take the chance to acknowledge that a lot of Janet's students are watching us right now. Tapa Sweeney from India, Alex from Pennsylvania, Judah, she's not sure where he is, but Judah, welcome all of you young people, you who may actually be wearing those boots that go to Mars. We certainly hope that you'll have that opportunity and do some of this exploring for us up close and personal. Before we get to some of the questions that are coming in, I've got one more to throw at you, and Penny, you touched on it, but it's a question that Explore Mars CEO Chris Carberry posed before we started this, and that is whether what we have learned about both how we might handle isolating ourselves from life on Mars or anything else in the field of astrobiology might have helped prepare us to deal with the challenge that we're facing around this planet right now, the pandemic. I mean, do you see any relationship there?
Yes, I do. I think that one of the things that this horrible circumstance will maybe help is eventually in better public communication. You know, when you are trying to talk to people who are not microbiologists or scientists of some other sort about microbial life, it's very hard to communicate the size of these individual entities, their capabilities, and just how easily spread they are. You know, in many cases, that's very benign. There are many microorganisms that we need in our environment. They basically run a lot of the biogeochemical cycles on our own planet. So on balance, they're beneficial. We only sort of notice them on the broad scale when they're deleterious, like in the case of the COVID-19. But you can derive some lessons from this. You know, the fact that we have a new virus on the scene means even though it's related to other Earth viruses and similar to others in its group of coronaviruses, it's many different properties. And so a lot of the scrambling that's going on now in the medical and research communities is to try to figure out its properties. And so the way that we do that in real time is orders of magnitude accelerated compared to what we would have been able to do with something like this even 20 years ago. So within mere weeks, we had an entire genomic sequence for this RNA type of virus. And that was propagated around the world. And so the biggest issue is, you know, we are a world full of people with different traditions, different levels of technical sophistication, and different access to communication. And so it's the human response to that that's been the trickiest part. But one of the things that I think is important to communicate is that microorganisms, for the most part, are benign and absolutely essential to us. And so one of the things I don't want to see is an increase in sort of mindless germophobia from this. And, you know, that could be a natural outgrowth of this. But we are talking about studying microbial scale life on another planet, although we're mostly looking at bacterial size things. And if you look at a bacterium, you can probably line up maybe 80 or 100 of them across the diameter of one of your hairs. But if I were going to put viruses end to end across the diameter of your hair, I would probably put 1,000 or 2,000, right? So they're even more minuscule. So I think we're mostly focusing on bacteria size organisms. And so those are actually much easier to control and work with for the most part than the viruses, because the viruses are tinier than dust specks, whereas the bacteria are much chunkier, and so our methods of controlling bacteria and working with them in many ways are easier.
Jim, anything to add from the NASA perspective?
Well, yes. Penny did a wonderful job with explaining the various aspects of that. What's critical also to understand is, viruses aren't considered alive. They really are cellular parasites, if I were to describe them in some way, and they invade the body and they have some genetic material associated with them. But in reality, for them to live and grow, they actually have to co-evolve with a host. And so when we think about bringing material back from Mars that is alive, that life has perhaps a second genesis, perhaps is related in some way to us in terms of the fact that it started in a similar environment like Earth, but it has a completely different evolutionary track. And so the current thinking is, yes, we're going to quarantine those samples. Yes, they'll be in what we call a biolevel 4 facility, where they handle anthrax and everything else, and it will be closely monitored. But I think, as Penny points out, our ability to understand the microbial and virus environment will allow us to use those current tools to interrogate those samples and begin the process of releasing things to the science community, which will be really important to do, because that's where those laboratory equipment really comes into play. In many places around the world, that will really tease out some of the most spectacular science in terms of really having a deep understanding of that planet than we can dream of today. So those are all just right around the corner, and I'm hoping also to be around when we start cracking into that next generation.
You and me and Penny, all of us, and everybody watching this program, I am sure. All right, we are now at approaching about 10 minutes of the hour. But I have also heard from both of our guests, Jim Green and Penny Boston, that they might be able to spend a couple of extra minutes of bonus time with us. Yep. So let's go ahead and start getting to your questions. And I know that many of you are submitting them through the Zoom window, but we also got a couple. Well, I'll read one of these that was submitted ahead of time to Explore Mars. And this came from Andrew Planet, how appropriate, in Gibraltar. And so we also welcome our international audience for today's program. Andrew says, if we ever find native life on Mars, and if it had the same method of storing genetic information as we all share here on Earth, would that mean that biology originated independently at both worlds, but had evolved analogously, because it was a good solution, I guess, or that they've evolved out of a common ancestral biochemical panspermia? There's a term that we all love. Penny?
It's one of the big debates that we have, and we're not sure how to make that decision yet. If and when that arises, then we'll have to do a lot of investigation. What I think most of us are hoping for is what Jim mentioned, which is a true second genesis, where the life on Mars would be so different that we wouldn't have this conundrum. But if the life resembles ours in terms of its basic biochemistry and molecular machinery, then we're going to be faced with this conundrum. Is it regional, shall we say, panspermia within the solar system? Or is it that it's such an optimum solution to make life the way that we do that it got reinvented again? And it's very hard to know how to actually go forward. And so that's where detailed work in the future would have to come to bear. I think there's no easy answer.
Jim, you're nodding.
Oh yeah, so I think the concept of, okay, we're going to look at that life, and if it is indeed RNA, DNA, has all the right stuff, we're going to want to see if there's a common ancestor. Okay,
Yeah.
That's how that would relate to us. But as Penny points out, that's going to still be incredibly difficult, and it's really because of the fact that life has that attribute that it has to evolve, and that environment is so different than ours, on a daily basis. The temperature swing is on the surface alone is 170 degrees Fahrenheit in one day, and it's bathed in ultraviolet light, and so maybe this life has found a way to repair itself, or to survive in those environments, and that's tremendously exciting. If we can tease that out and it relates to our life, then we have new medicines, new approaches. It's just a complete revolution in our ability, perhaps, to live and grow on other planets where there are extremes. So this is just really an exciting opportunity for us that we just can't pass up. Let's find this life and bring it back.
That's thrilling. Jim, I'm going to throw this next one to you, and it comes from one of Janet's young fans, Tapa Sweeney. I apologize, Tapa Sweeney, if that's not even close to how your name is actually pronounced. She says, how can we guarantee that we are not putting life forms, our own biology, on Mars from all the probes that we are sending to crawl around on the red planet, even though we try to sterilize the stuff that goes down to the surface?
This is a really good question, because indeed it's all about that planetary protection guidelines. We early on through COSPAR and had this international agreement that Mars would be a place where potentially life could have been, or even is extant, living there today. And so consequently, those guidelines tell us that there's a level of sterilization that we want to do. We want to be able to have an opportunity not to contaminate that planet while we learn much more about what that planet is like. So we've gone through quite a program in NASA, and many of the other agencies have stated they have too, through those processes of learning how to clean a spacecraft, learning how to be able to ensure that there's minimal or nearly as close to zero bioburden, we call it. That would be types of microbial or other types of life from Earth on the spacecraft as possible. And in particular, those places that actually touch the surface. And so that whole topic has evolved over time, for which many new and exciting techniques have come up, and we're still doing original research in that area. So we plan to keep Mars as pristine as possible in terms of not contaminating it as we possibly can. And of course, once our rovers or landers are down on the surface, they too are bathed in ultraviolet light, which really takes out another layer of bioburden that occurs by us launching it and getting it there in some sterilized form. We can't completely sterilize it, but the environment is also a sterilizing environment. So I think we're overall internationally doing real well.
And I have to apologize. That question actually came from Michael. I don't know where he is. I apologize to you, Michael, and to Tapa Sweeney. Tapa Sweeney did have a question, though, and it's more a geology question about rocks on Mars. Are they similar to what we know we have on Earth? And I think the answer is yes, right?
Yeah.
But I mean, are there geological implications for our search for life on Mars? I don't know which of you might want to answer that.
I'm willing to jump in. I have one of the slides and the backup slides, which is my number 3, I think, for Wade out there. One of the big revolutions in thinking of the last 10 or 15 years has been the degree to which life on our planet has affected. So slide 3, which would be oh wait, let's see.
Is that your last one? Biominerals?
Yes, it's
Yes.
biominerals. I'm sorry.
Oh, it's number 7. There we go.
Sorry. We're learning to do this online thing here. So the biominerals in the solar system, it's been pointed out by a guy named Bob Hazen, who's at the Carnegie Institute in Washington, and a number of his colleagues more than 10 years ago now, that if you look at the early solar system and a lot of the bodies in our solar system, like small bodies that have not had extensive geological evolution and don't appear to have life, that you got 12 primitive minerals. And on Earth, we have in excess now, actually, probably about 4,500 known minerals on Earth today. Many of them, I must say, are found only in caves. So just giving caves a plug here.
Okay.
But, you know, in their thinking, the mineral wealth that we have here on our planet is due to abundant liquid water and the fact that we have tectonic, plate tectonics that helps to mix up the crust and down to the mantle and so forth. But the rest of that 4,400, 4,500 is due to the geochemical and biochemical interactions of life with the geology of the planet. And so one of the things that I think we're very interested in is not just the bulk chemistry of Mars, but where we find a lot of these unusual minerals on Earth are places, micro niches, sometimes hidden niches, many of them in the subsurface or at the bottom of the ocean, or in rock fractures where the life is actually working to create these minerals. And so this is another whole class of biosignatures that I think we did not really grasp in its complete form until Bob Hazen and his colleagues pointed that out. And so I think this is has been a revolutionary concept. Yeah, the slide that that Wade just put up now shows the life-produced gases, which relates to Jim's early remarks today. And then the biological molecules, there are molecules that we can see from space. Chlorophyll is the most abundant protein on our planet, and it drives the solar production of biology. But there may be other pigments that we could find, and then of course there's morphology. So when you add all these things up together, biominerals, real fossils if we ever find them, microfossils, and my favorite is Baby Yoda, so I'm still holding out hope for that.
Let's see.
Well, indeed.
Go ahead, Jim.
Let me just follow up by saying, Curiosity has an experiment that actually looks at the mineralogy, and so consequently, over its 5 years of operation on the surface, it brings in material and does X-ray diffraction, and then that pattern tells us the mineralogy, the structure of how these things are put together. And right now, I think the count is well over 300 individual minerals, and of course, that we have found and discovered. And then the first thing we want to do is that a new mineral? Is that something we don't have, or do we have it? And in every case, we've said, yes, that is also exists here on Earth. But the concept then of bringing back those samples, bringing them back and actually having in the laboratory an opportunity in that rock record to look at the change in mineralogy over time, because we have cored that rock and we have that time record, is going to be incredibly important for us to understand how Mars has evolved, and evolved in a way that's different than the Earth, because of, perhaps its distance from the sun, or it's the lower mass, or it didn't have a magnetic field that kept it preserved for as long as the Earth has had. all those other factors then come in to really understand and figuring out that history of Mars. So this is really an exciting time, and that rock record is just so key to being able to tackle those questions and those things that Penny was bringing up too, all important.
Let's see if we can squeeze maybe a couple more questions in here. We
Sure.
are now into bonus time, and so we thank all of you for sticking with us for over an hour here. And this one comes from, if I can find it again, from Gene of Talking Space, another great podcast. For both of you, actually, given the fact that there is an interest in Mars colonization by several commercial entities, what would the impact of microbial life on Mars or Second Genesis due to these commercial ambitions? Jim, why don't you start with that one?
Well, the planetary protection guidelines that come out of COSPAR are implemented by each of the space agencies. And so our commercial entities here in the United States would indeed fall under those same guidelines. So indeed, they are just as interested as NASA is in terms of what that means relative to the exploration of Mars. So we're working together to be able to think about how we would approach colonizing Mars in the sense of that exploration zone. Commercially, we expect them to be major partners. We expect things to be landed in those areas, things that can be put together. And in fact, they may eventually have commercial astronauts that will go. But because they are US companies, they will follow the US implementation, the NASA implementation. And that's why they're interested in these topics just as well as we are. We plan to do, the right thing. We think we can, but to do that, it requires these samples coming back for us to really interrogate them, learn so much more about Mars that will allow us then to revisit those guidelines and come up with a way that makes it even easier to explore Mars.
Penny, I'm going to go right to this last one and throw it to you. It's partially personal. From Rachel Tillman. What inspired you to become part of the search for life? And really a separate question, but there's some relationship. How can we integrate everybody who's interested in this, not just NASA, into sharing these findings, making them part of the public education system, like Rachel says during Apollo, where, I can actually remember schools with televisions rolled into the classrooms so that we could watch the latest mission landing or return to Earth. I mean, have you thought about this, Penny? How do we share the passion that you and Jim and everybody else watching this obviously feel? Hey, Penny, you're muted there.
I think it muted me itself.
There you go.
Our computer are becoming sentient as we are all home working.
Speaking of
Second
finding
Genesis, yes.
biosignatures that we might not recognize.
So Rachel asked what inspired me. I was a very curious little kid, like most kids are, right? And I started reading science fiction very early. That was it. I wanted to get in my rocket ship and cruise the galaxy looking for things with long tentacles and 15 blue eyes, and I still do. So I think that, the arts, the science, the literature, all of that comes together and inspires us. I come from a family derived from many different countries and that has moved around a huge amount. And so there's that taste for exploration, in my background in terms of Earth. But I think the joy of what we do is impossible not to communicate. I know Jim and I and many of our colleagues go out of our way to do public events, large and small. So, I have done many discussions with fourth grade classes and elder hostels and gem and mineral groups and anybody that wants me to talk, if I can fit it in, all the way to, big television broadcasts that are commercially produced, or PBS or whatever. And I know Jim is the same way, and he has his own podcast, which, you know, serves that function. I show up to things, and I can't keep it inside. I mean, this isn't just a job where you kind of punch in the, you know, 8 o'clock and go home at 5 and stop thinking about it, right? This is an all-consuming lifestyle, and it has saturated my entire life. And even when I eventually go off NASA's payroll, I don't plan to go off the scene entirely, you know. And that this is true of so many of our colleagues. I think, Jim, you will have seen that too. You know, they retire, maybe they're not picking up a paycheck, they're picking up a retirement check, but they're still actively doing research, they're actively thinking and writing and talking to folks.
Yes, indeed. In fact, it's going to be the case. I can see it now when we land on the moon, where that teacher is going to say, "Class, take out your iPads," and they'll all bring up, you know, the landing where the first woman, you know, and maybe even the next woman, but at least the next man will step on the surface of the moon. Now, I was alive in high school at the time of the lunar landings, and it was just awe-inspiring, even with the grainy, yucky, you know, black and white TV.
Yeah.
And so today we're going to be doing it in high definition, and the colors will be spectacular, and the shadows will be long, and it will be incredibly eerie, but it will be just as inspirational. So everyone, you know, that hasn't seen that original lunar landing of any of the Apollo astronauts have really got a treat in store for them, and that's coming up.
What a great way for us to end this wonderful conversation. I want to thank both of you. There truly were no better people to be a part of this discussion of life on Mars and why we, examples of life down here, are so excited about it. Thank you, Jim Green, NASA Chief Scientist. Thank you, Penny Boston of NASA Ames, astrobiologist.
Thank you.
And thanks to all of you for tuning in, for joining us for this, and to Explore Mars, for making it all happen, and the great people there who have been helping us out: Wade, Janet, Chris, Ron Sparkman, Adrienne. It's just been terrific, and I know that this is just the first of many that Explore Mars plans to bring you. I'm Matt Kaplan, the host and producer of Planetary Radio for the Planetary Society. I hope you'll check out our podcast, Planetary Radio, and keep looking up there at Mars, because we're there, and we're going back. Thanks again for joining us. Have a great day and stay safe.
Live long and prosper.
Live long and prosper. Thanks, Matt.
And good morning, everybody. We are here. It is very, very early in the morning, and it's time for the live stream to begin. We have our CEO, Chris Carberry, joining me, and we are as wide awake as we can possibly be, because It's time.
Finally. Good morning. It's much more morning for you than me, but it's early enough here.
It's early enough. Yeah, I think we've got a couple hours before the sun comes up. So it's a big day, Chris. So let's just start it off and let everybody know what's going on. Perseverance, we hope, is going to Mars this morning. The weather looks clear. Last we checked, there wasn't a cloud in the sky, which is always great news. So this might go off without a hitch. And let's be honest, we need one of these wins for 2020, right?
It has been a challenging year indeed. Yeah, we certainly need this. I mean, it would certainly be a shot in the arm and a shot towards Mars. But this, really important mission, Perseverance, for getting humans to Mars. As everybody who I'm sure watching this broadcast knows, exploring Mars. Been around 10 years committed to getting humans to Mars by the 2030s. And Perseverance really advances that goal with all the suite of experiments it's carrying, including the Ingenuity helicopter, which not only will that be able, if successful, probably the first time we've flown a helicopter or any aircraft on Mars, but it'll test out a technology that'll not only show wonderful views of Mars, but think about the applications. When we send humans there, think of how we use drones here on Earth. If we can prove out this technology, this will be an incredible assistance to future explorers on the surface of Mars. If they can send, little drones ahead, down canyons, into lava tubes, caves, spec out the areas ahead of them. So it'll be a wonderful asset. But also things like ISRU, the MOXIE mission, utilizing the atmosphere, and the search for life on Mars, and even a sample return. So this mission has so much going for it, far more than any other previous one, and so many that have direct relevance to getting humans to Mars.
And so you've been through some launches before. So I don't think that I've ever asked you that. Have you been to a launch? Have you seen one of these Mars missions head to the red planet, or have you seen all of them in the last 10 years? Maybe that should be
sadly, while I've actually been able to arrange other people to go to the Mars launches, I haven't gone to one myself. I've been to a shuttle launch, but have not seen one of the Mars missions launch. And I was actually, frankly, this year I was originally planning on going down there, but I don't know, certain circumstances prevented me from doing so.
Yeah, I think we were all planning on that. It was supposed to be that. It was. We were really excited to just be involved this year, and we're all kind of a little bit on the side. But what's great about the virtual world is it allows us to be able to do great events just like this. And speaking of which, we have our first guest of the morning who is joining us right now from Aerojet Rocketdyne. Let's welcome Ashley Reiser. Ashley, how are you doing this morning?
Good morning, Ron. How are you? Hi, Chris.
Doing good.
Good morning.
We're glad to have you on as our first guest today because Aerojet has such a huge piece in what's going on. So do you want to talk to us a little bit about Aerojet's role in the Perseverance rover?
Yeah, absolutely. So we are on multiple parts of the mission, going from launch to entry, descent, and landing on Mars. Even after that, we are going to be helping power the rover during the surface operations part of the mission. So starting with launch, we have a full suite of propulsion solutions. So we're providing the 4 solid rocket motors, which are the AJ-60As. Those are going to help give an additional 1 million pounds of thrust to get the rocket off of the launch pad and exit Earth's atmosphere really quickly. Because we have such a small window to really get to Mars and utilize its close orbit to Earth, you want to make sure that you're able to do it right and you're able to get off the ground really quickly. So that's why it's really important that they're using the really reliable propulsion that we offer. And then on the Centaur upper stage, we have the RL-10 main engine, and that's going to help put the Centaur on the trajectory to Mars. We also have 12 reaction control thrusters on Centaur that are going to help with yaw, pitch, and roll, as well as settling burns. And then we also have a lot of propulsion on the spacecraft. We have, for the entry portion, 8 107 MR107U thrusters. And those are basically going to help the spacecraft stay oriented, make sure that the heat shield is facing forward so that when it's going through atmospheric entry, it's pointing in the correct direction. And then lastly, when it's ready for descent and landing, we have an additional 8 thrusters that are actually going to have throttled levels of thrust. It can go from 8 pounds of thrust to about 800 pounds of thrust. And those are going to go up and down to help the descent stage with the sky crane basically head down to the surface of Mars and then hover so that the sky crane can execute its maneuver to actually put the rover on the surface.
So is there any new technology that we might see today that people haven't seen before? Anything that you're in particular excited about?
So one thing that's really cool about our technology is that it's all reliable and extremely flight proven. The Perseverance mission is very similar to the Curiosity mission. So you're going to see a lot of the same propulsion that we used for that, from the launch propulsion all the way down to the thrusters that are helping lower the sky crane. These were all used on that mission and it had a 100% success rate. And so we're really excited to see this perform just as well as the Curiosity mission did.
Chris, I'll throw it to you.
Yeah, no, actually, can you tell us a little bit about Aerojet's history in Mars missions? I believe Aerojet has been part of every U.S. mission to Mars.
That's right, Chris. So we have a really strong history of supporting Mars missions dating all the way back to the Viking landers. So as you know, that was the first time we landed a spacecraft on another planetary body. And what's really cool about that is that the MR80 engines that I talked to you about that have the throttling capability, those were actually made for the original Viking mission. And so they performed so well. JPL came back to us and said, you know, we would like to have these made again. We'd like to do a powered descent onto the surface of Mars for future missions. And so we did an upgrade of those for the Mars Science Lander with Curiosity. And those are going to be in effect in February when we land on Mars.
Are there any differences between this mission, meaning from the Aerojet perspective, and what Curiosity did? Or is it pretty much exactly the same mission?
No, I mean, it's pretty much the same. You know, there's always going to be small tweaks and updates to some of your products, but what you're looking at is pretty much going to be the same thing that you had in Curiosity. And, you know, as they say, if it isn't broken, don't fix it.
Very true. Now, was Viking your first mission, or which one was Aerojet's first mission? Obviously, there were previous American ones. So what was the first one that Aerojet was involved in?
So I think that the actual first landing that we had was Viking. We're also on a lot of orbiters that are still active around the planet. But going back, not only were we on the Viking mission, but we also followed on with the Viking 2 mission. We were also on, apologies, wanted to just reference my notes really quick. We were on the Pathfinder and Sojourner mission. We also helped with the exploration rovers, obviously Spirit and Opportunity. We did the powered landing for the Phoenix lander. And as you know, we covered that we had an extensive role in the Mars Science Laboratory with Curiosity and have a huge role today in Perseverance.
Cool. Now, I just have one more question and I'll hand it off back to Ron.
Yep.
But, you know, while Aerojet didn't create the actual sky crane, you obviously have the retro pack. When JPL approached you and mentioned this concept of the sky crane, do you have any insights on what the reaction was at Aerojet?
Yeah, so obviously I wasn't there at that point, but from stories I've heard is that this is a little bit out there. This is kind of a wild idea, you know, but our engineers, they're really up for everything. You know, they think very outside of the box, and we had already used those throttling thrusters to help do an actual powered descent of a spacecraft on Mars. And so we thought, you know, this is definitely something that's doable. So let's take this proven technology and try to make it help with this sky crane application.
It was certainly unusual. I remember back in 2012, you know, just all the speculation on this crazy technology. And of course, so many people were betting against it. I mean, I remember even with some of the people who are fairly well known within the space community, there was definitely doubts. But boy, did it perform brilliantly and perfectly.
It's such a cool application, and it's really neat to see the various ways that you can land on Mars, going from a strict throttled descent where it actually lands on Mars to the really awesome airbags. But I would have to say that if I had to pick one, the Sky Crane's definitely my favorite.
And I lied, actually, Ron. I have one more question. So,
Sure.
on launch, so what role does Aerojet have on the launch today?
Yeah. So on the launch, we are providing 4 solid rocket motors. So those are the AJ60As. And those are basically strap-ons. As you know, the Atlas V is going to be in a 541 configuration today. And the background of the configuration number is actually pretty cool because it ties a lot into our role. So 5 being the meters of fairing that there is. And then the 4 actually counts for the number of strap-ons, which are our AJ60As. And then the 1 is reflecting the 1 upper stage motor, which is our RL10, which is really great. It's super flight proven. It's a workhorse in the industry. And we actually just celebrated our 500th flight of the RL10 in March this year. So you're going to see some really great, really flight proven technology that's going to set Perseverance straight on its way to the Red Planet.
Yeah, 500 flights is pretty impressive. You know, hopefully we'll get into a world soon where 500 flights is just not impressive at all. You know, we've been in this almost test mode since the beginning of space flight. So hopefully we're finally getting to a point. We're about to enter the new age, whereas you do 500 flights in a year or something like that. But 500, yeah, hopefully we're almost there. But Ron, questions?
Yeah, no, just one last question before you head out. If there's anything in particular exciting that's coming up for Aerojet outside of the launch that you want to share with us, and then your social media handles for people to be able to check out what everybody is up to over at Aerojet.
Yeah, absolutely. So another really awesome mission that we have a very big role on coming up is the OSIRIS-REx sample collection. So OSIRIS-REx is currently surveying asteroid Bennu, and it's going to be performing a tag and go. And it's going to basically extend an arm and grab a sample of regolith. And it's going to be able to bring that sample back for us to analyze. And so the cool thing about this is Aerojet Rocketdyne provides all the propulsion for this mission. So as it went out to the asteroid, as it did circles of the asteroid, as it's going back and forth and surveying it, and even when it takes the spacecraft down to the surface, very, very closely, but not quite touching it, that's all our propulsion. And it takes a ton of expertise. It's very minute maneuvers. And so it's going to be a really big milestone for us. So definitely stay tuned for that. I believe the sample collection has been pushed back a little bit, and it's going to be in around October. And
go ahead.
Of course, if you want to follow along with us, we'd love to have you guys join us on our journey. We are on Twitter at Aerojet RDYNE and Aerojet Rocketdyne on Facebook, as well as Instagram. So follow along with us.
Actually, I do have one more question.
Chris, you keep having these questions come up.
He woke up ready today, so you just got you're the first one.
I've been drinking caffeine all night, and moving to humans to Mars. So what from the Aerojet perspective, when do you expect humans to be on the surface of Mars? Do you think we'll be there as plans are by the mid-2030s?
I mean, we're sure hoping. We are not only part of some of NASA's science missions, but we actually play a really big role in the Artemis mission. And as you know, Perseverance and other missions that we have going that are robotic right now are really going to lay the foundation for us to eventually have humans go to Mars. And that's going to happen through NASA's Artemis mission with the SLS rocket, which we're providing the 4 RS-25 engines for, as well as an RL-10 upper stage engine, and the Orion spacecraft, which will eventually carry crew. And we are providing reaction control thrusters on that, as well as auxiliary engines and the main engine for the Orion service module.
Very cool. Well, hopefully we'll be able to get there in that time frame. I'm very optimistic with everything happening these days. So, Ron?
Yeah, no, actually, thank you so much for coming on and joining us and telling us a little bit about what Aerojet's up to with the launch today. And couldn't have picked a better first guest. So thank you for coming on and saying
Thank
hello
you,
and filling us in.
Thanks, Chris.
Thank you.
And as Ashley heads out, who better to talk to today about what's going on with the Rover than Hoppy Price, the man, the myth, the legend. So, Hoppy, how are you doing this morning? How are you doing this morning?
I'm doing great. Yeah, I'm really excited. Looking forward to this launch. We've been working for years for this.
And for those that don't know, Hoppy is the chief engineer of NASA's robotic Mars exploration program at JPL. So who better for us to talk to next about what's going on? For those that may not know, maybe they're just joining the stream because we are simulcasting this out to a lot of different channels. Can you tell us what the Perseverance rover is, what its mission is, and why we're all so excited about it today in the space industry?
Sure. So the Perseverance rover, if you just look at it and look at the sky crane and everything about the system, it looks pretty much like the Curiosity rover, but there's a lot more to it than Curiosity because it has new science instruments, some better life detection equipment, looking for the types of material that might have supported life in the past, and most importantly, it has a drilling system. The adaptive caching assembly is able to collect up to 40 samples on the surface of Mars, and these are core samples. So we actually drill into the rock and are able to bring out a sample that is about the size of a big piece of chalk, like from back in school days, if you had chalkboards, that's about how big these samples are. And some of these samples will be kept on board the Mars 2020 rover, and others will be deposited in caches on the surface, all for the purpose of returning these samples to the Earth. And we're working towards a mission in 2026 to launch a sample return lander, which will be a different kind of vehicle than the Perseverance rover, but it will have a Mars ascent vehicle to actually launch the samples up into Mars orbit. And then we're working with ESA, the European Space Agency, for them to build an orbiter to be able to retrieve these samples in Mars orbit and then bring them back to the Earth. And Langley Research Center is working on a Earth entry vehicle to actually bring the samples to enter the Earth's atmosphere and land them hopefully in Utah, where we can pick up the first samples from Mars. So Perseverance is very important because it is the first mission of Mars sample return.
So, I mean, the next question I think for maybe the uninitiated is, why is it important to science to see if there is life on Mars? Why do we want to know if there's life on Mars? So I mean, for us, it obviously is exciting. Everybody sees the movies, but it means a little something different to folks like yourself.
Right. So what we're actually looking for is past life on Mars, evidence of fossilized life on Mars. We believe on the surface of Mars, in the area where Perseverance is going, it's very hostile to life now. But about 3.5 billion years ago, the conditions on Mars, from what we can tell, from what we've learned from Curiosity and from Spirit and Opportunity, is that the conditions were very much the same as there were on Earth. There were probably even hot springs and lakes on the surface. And so life evolved, microscopic life evolved pretty quickly on Earth once the conditions were adequate for life. And it's possible that life evolved in the same way on Mars. And so we're looking for evidence of that because we think the conditions were suitable for microscopic life for maybe 500 million years or so or more. And we're hoping that in the clay deposits and the sedimentary deposits that there is evidence of past microscopic life. And so we want to core into that material and bring back those samples to be analyzed on the Earth. We really can't take the instrumentation required to do this kind of a search to Mars because this is very heavy equipment, very power intensive. We're talking about scanning electron microscopes and spectrometers. And so really we need to bring the samples back to Earth to be able to examine them here.
And Chris, I know you got some questions.
Yeah, no, absolutely. So Hoppy, a couple of questions. First off, what, from an engineering perspective, what do you think is the most complicated, the most challenging, well, the most challenging engineering challenge of this mission? And my second question is, which of the experiments, which parts of this mission are you most excited about?
Well, I think the most challenging part and what's the biggest difference from Curiosity is the sample collection system. And it's a very complicated mechanism. It's also greatly complicated by planetary protection because each one of these tubes is completely sterile. And the requirement we had is that there are no microorganisms from Earth on these tubes. And so when we have to take a tube out, have to put a drill bit on the end, I have to transfer it to the arm that's going to actually do the drilling. We have to position it, have to drill into the rock, and then extract it. And when we drill, we actually have to break off the core sample. So you can trepan drill a core, but then you have to break it off so that you can pull it back up and keep it in the tube. And then there's a sterile cap that we put on the tube, and then we store it in this carousel in the belly pan of the rover, and we save all these tubes. So just that whole mechanization was very challenging for us. I mean, of course, the sky crane and the rover, that's all very challenging too, but that's mostly a rebuild from Curiosity. So the new challenge for us basically was a sample collection system. There are some amazing new science instruments on there. Some of them were built at JPL. Many of them were built at other institutions. And then we also have an experiment to support human spaceflight, which is the MOXIE experiment, and that's to make oxygen from the carbon dioxide atmosphere of Mars. And that was also a very challenging instrument too, but we're hoping that will work quite well and make several grams of oxygen, each day.
And which one, just to repeat my earlier question, which one are you most excited about?
Oh, it's collecting the samples, absolutely,
Okay.
yeah, to bring back to the Earth, yeah.
Interesting you brought up the planetary protection issue, and we'll certainly be talking to Jim Garvin about this when he comes on a little bit later. But certainly a topic in the press lately as NASA's now re-examining the limitations of planetary protection. And for those of you listening, I think probably most people listening know what planetary protection is. But for those who don't, actually, why don't you, Hoppy, explain what planetary protection is?
So there's two parts of it. The first part is the forward contamination. So we don't want to contaminate Mars with Earth life if it's in a special region where that life may propagate. But actually, one of the reasons why we have a requirement to have no microbes on the actual sample collection as equipment is because when we bring these back and we examine them, if we see a microbe, we want to make sure that it's a Mars microbe and not an Earth microbe. In order to further protect against that, we actually take samples all over the rover every day while it was being built. And we have done a genetic inventory of all of those samples. So if we do see evidences of life there and we find DNA, we can check that DNA to see if it matches the DNA that was on the vehicle before it was launched. So even though the sample tubes are sterile, there are other parts of the rover that aren't completely sterilized. They may have a small amount of spores. And so we want to make sure that if we see something in the sample tubes from Mars, that it isn't something that we brought to Mars. And so we're able to do DNA matches on that.
Yeah, we have confirmed there's life on Earth. So we can rediscover that.
Have we?
Now, backwards contamination. You want to explain that?
Sure. So we also want to make sure that we're not bringing back any viable Mars pathogens to the Earth. And although we think it's extremely unlikely that anything could have survived on the surface of Mars for the last 3 billion years, when we know that it's been inhospitable to life, and we're drilling core samples that aren't that deep. They're only maybe they're less than 10 centimeters deep, and so the galactic cosmic radiation would have just sterilized everything to that depth. But there is some slight chance that there may be special regions on Mars, like exposed ice scarps, and the wind has blown some kind of hypothetical Martian pathogen over, to where we are, which is far away. And so when we do the Mars sample return and we bring back the tubes, that orbiting sample container, which has the samples, will be captured in a way that it will be completely encapsulated by the orbiter's capture mechanism. And it will go through a process where we seal it up and we actually break the chain of contamination with Mars with seals that are heat sterilized. And then there's a secondary containment that's put around that. And so we want to be absolutely sure that all the Martian material is completely sealed up in double sterile containers for return to Earth.
Very interesting. So Ron, do you have other questions? I do as well, but I'll hand it back to you, Ron.
No, go ahead. You're killing me right now with the
Yeah.
questions. You're on top of it. So like
well, as for the Ingenuity helicopter, now that's really cool. And what are the expectations of that technology? I mean, just for the cool factor, I think it's one of the most interesting one. It may not be the most scientifically important one like search for life or sample return, but it's certainly cool. It also certainly has applications for when we send humans to Mars. So what are your perspectives on that and the challenges of that mission?
Well, it was very challenging because the atmosphere on Mars is about equivalent to the atmosphere on Earth at 100,000 feet. So the challenge is, can we design a helicopter that could fly at 100,000 feet on Earth? And so, the engineers were able to come up with a design that did work. It's counter-rotating blades, and they're very big blades, and they rotate very fast. And we've tested it in chambers on Earth that simulate the Martian atmosphere. And so we are convinced that the thing will be able to fly and that we'll be able to control it even in that thin atmosphere. And so this is really just a performance experiment to get data, to test out the control software, and pave the way for future missions where we could have bigger helicopters that could go to areas of terrain where our normal rovers wouldn't be able to go, and to do some aerial reconnaissance. And then for human missions to Mars, there could be some value for telecom relays over the horizon, being able to scout ahead, and also to collect some kind of samples, like if we wanted to go on a cliff or some area that is really hard to get to any other way, that we could fly there and be able to collect a small sample and bring it back to look at it.
Do you think, I know this is a lot of big questions here, you have to prove out this little technology first, but do you think that there is any prospect of scaling it up, whereas you could actually eventually create aircraft that could carry people on Mars? Is that just too big a challenge, or is it a thin atmosphere?
Yeah, we certainly plan on scaling it up, and we would be able to carry maybe even a few kilograms of science instruments. But to build an aircraft big enough to carry people around and spacesuits and all of that, I think that's a tremendous challenge from a size standpoint and an energy standpoint, the energy required to power that. So, I'll never say never, but I don't think we'll see helicopters carrying humans around in my lifetime or my children's lifetime. But I think we can see some exciting uncrewed applications that would make great use of helicopters.
Very cool, Ron.
Yeah, actually, so Ashley from Aerojet is still with us. So I thought it'd be great to talk a little bit about how Aerojet is helping out, on the mission, and kind of get a little bit of the viewpoint of the two of you on how organizations work together to make these things happen, right?
Well, of course, we've worked with Aerojet for many, many years on all of our missions. And you're asking about what was the earliest mission. I'm not sure if Mariner 4 had an Aerojet engine on it. Maybe it did. I don't know. That was the first spacecraft that we ever sent by Mars in 1964. But I can say that we really like the MLEs, the Mars landing engines. Those are really great. That really has enabled the Sky Crane and probably our future landers too. So that's been incredibly helpful.
So,
and yeah, I was just going to say, so you all are helping out with powering the rover. So you want to tell us a little bit about that, Ashley?
Yeah, absolutely. And just to hop back to Happy's point, I know that you said, you really liked the engines that we have to help land on Mars. And one really cool thing is that if Perseverance, which it's going to, has a successful landing in February, this is actually going to be the 9th successful landing of a NASA mission on the surface of Mars. And the really cool thing is that it's not only the 9th successful landing for NASA, it's the 9th successful landing with a mission propelled by Aerojet Rocketdyne.
Mhm.
So if you go all the way back to Viking, if you go through the exploration rovers, Phoenix, Mars Science Laboratory, we were on all of those. So it's a really cool thing to be able to look back and tie that reliability to the actual success of these missions. Just had to get that point in there.
Right.
But yes, Ron, back to your question. In addition to providing a lot of propulsion, I know that folks always, when you think about Aerojet Rocketdyne, you think about propulsion. But one really cool thing is that we're also very big in the power systems community. And we are providing the power source for the Mars rover. It's called the MMRTG, the Multi-Mission Radioisotope Thermoelectric Generator, which is quite a mouthful, but basically just a very fancy name for something that is the actual power of this rover on Mars. And the MMRTG is powered by the decay of plutonium. So it is radioactive. So you're not going to see these, going around in the streets on Earth, but it's really great on Mars because unlike other rovers that have had to rely on solar power to operate, the MMRTG doesn't need that. The heat that it generates powers lithium-ion batteries, and this helps keep all of the instruments on the rover operating, and it gives it the unique ability to be able to operate during the winter when exposure to the sun may not be as much as it is throughout the rest of the year. It allows it to operate during day, during night, and even during dust storms, which, as you know, can have a really detrimental effect to rovers such as Opportunity. So Curiosity was actually on the planet when the major dust storm happened that took Opportunity out. And, it's still chugging along today, well past its mission, its expected mission deadline. And, we're really excited to see how long Perseverance is going to persevere with our power system when it gets there.
Awesome stuff. So we actually have another one of our guests joining us right now, Dr. James B. Garvin. Good morning, sir, and welcome to the show today. NASA Goddard's chief scientist, and what a wonderful addition to the show. So glad to have everybody on today, and we've got some wonderful representatives from all across the space industry, and we're thrilled to have you. So, Dr. Garvin, how are you doing this morning? I know you're excited.
Well, I'm excited. As you can tell, Ron, it's always a fantastic moment to be going home. And Mars is waiting for us. And it's been a long time since we first thought about starting sample return back at the time of Viking. So now it's happening. Let's go.
So let's talk a little bit about past missions that have helped us get to where we are today. Obviously, there's been a lot that's been learned, and you've been a part of quite a few of them. So can you talk to us a little bit about your history with these Mars missions and what they've taught us to get us here now?
Well, thanks, Ron. So really, our story at Mars is so complete and compelling. It's really a tapestry. And so I first got involved with Project Viking. It kind of dates me. And Viking, as an intern, was an exciting time to watch our first foray to landing on another world beyond our experience at the moon. And that opened our doors to the mysteries of Mars, because Mars just was so beguiling, Ron. And thanks to Viking and missions that then followed, such as the Mars Global Surveyor, we were able to really transform how we thought about Mars. Instead of a quick, let's go look for life kind of planet, it became a system of systems to understand how the planets of our solar system that might be habitable work. We even invented a term. So for me, my story began with Viking, but it continued with instruments such as Mola. It sounds like a fish. but it was not a fish. It was a really daredevil instrument to map the topography, the relief, the up and down of Mars with lasers. And that gave us the maps we used to precision land missions like Perseverance and, of course, Spirit, Opportunity, and more recently, Curiosity. But for me, in the aftermath of some challenges in the late 90s, I became the first chief scientist for Mars exploration for the agency, and gave me a chance with my colleagues in the science community to shape this trajectory, to look for habitability records in the climates, in the rocks, in the polar caps, and transform our approach to understanding whether we're alone. And so the Mars program has done that brilliantly. And today, Curiosity, with magical measurements of organics, understanding cycles of methane, stuff that was unimaginable at the time of Viking, we're doing now, all against the backdrop of the still long-lived Mars Reconnaissance Orbiter, which I got to tell you guys was a really hard sell. And hats off to the team that done it, because she's still there, still mapping. She'll see Perseverance when she's down. So for me, this is just the next step in a story, Ron. And that story is one that says, we've prepared the way now to go to Mars and bring a piece of her home. And that bringing Mars home to the labs for the women and men to uncover, to do the forensics on Mars, it's so ready, because it's going to be our door opener for the women and men to go to Mars. So I'm just thrilled, because it's been 6 years since it's been 8 years since we first put forth to our administrator the idea to do a mission like Perseverance, and here she is, ready to go.
Chris?
Yeah. Hey, Jim, how are you?
Hey, Chris, I'm good. Waiting for Mars.
Waiting for Mars.
So just a real quick note, Jim, your microphone's just a little scratchy. If you can maybe wiggle it just a little bit, it might be sitting on that there. Just want to clear you up a little bit, because you're saying some awesome stuff.
Okay, is this any better?
Still about the same. Maybe unplug it and plug it back in again. Turn it off and turn it back on again, right?
All right, let me try it.
And I'll hold off on my question until you test. While we're waiting, Ron, why don't you sing a song to us?
Is there life on Mars? Jim, you have to unmute yourself, good sir. And it looks like you're there.
Any better?
Still sounds a little scratchy, but I think we can deal with it.
Around it, if we can go to Mars.
If we can go to Mars, we can deal with that. Yep.
Now, Jim, you mentioned earlier kind of the origin of Perseverance back then, the 2020 rover. Tell us how this came about. I remember when this was happening. I remember, the role, particularly of John Grunsfeld as well. And how did this come about?
So, Chris, great question. So here we were, driving, getting ready to drive Curiosity, I should say, on Mars, and we had prepared this brilliant program of executing what we call Mars sample return with our colleagues in Europe, and that program, unfortunately, was not executable. And so John Grunsfeld, together with Charlie Bolden and many of the leaders of NASA, got together a team. We called it the Mars Program Planning Group, MPPG. You got to have an acronym. It sounds like something you find in a used car lot. But a group of us Martians got together with the community and cast really a story of pathways. What should be the next mission that will open the door to eventually, of course, send human beings to Mars? And after 6 months of work, colleagues from the Jet Propulsion Lab, myself, Orlando Figueroa, and other colleagues at NASA headquarters, we put together the idea that what's now called Perseverance, this rover to produce caches of materials in the context of new multi-scale measurements, was the right next step. And that was presented to the administrator, Charlie Bolden, and his team in fall of 2012. And together with leaders like John Grunsfeld and some of the rest of us old Martians, that was the plan. And I'm just dazzled, because then we competed the payload. I mean, it's like the Olympics does science. And we have this incredible set of vision systems and of instruments of all sorts on this rover. I mean, I'm, Chris, dazzled beyond belief that it's all come together, including the first ever, airborne vehicle to pave the way for something that might go beyond the roving on the surface we do. And so Ingenuity will do that the same way I just flew drones and new islands in Tonga last year, and we'll be doing that on Mars. So it came forth, Chris, through a process that involved taking the best minds of the women and men who work on Mars, putting them together into a program plan that has been executed brilliantly by NASA, by the Science Mission Directorate, by JPL, and I'm just, like I was when we first thought about even doing Curiosity, I'm just dazzled that we're doing this stuff. I mean, that's amazing. We take it for granted. We're on Mars today.
Yeah.
Day 2800 something, still driving, thanks to those MMRTGs you heard Ashley talk about. And we're still imaging with systems we expected to work for one day. Well, they're 2,850 days later. Not too bad. So I'm looking forward to Perseverance because I think it will open our eyes to the stuff we want to bring home. And that's going to change everything. Those young girls and boys out there, they'll have real Mars, and not the randomized Mars from the meteorites that a lot of us adore, but the specific Mars that we want to bring home, as artifacts for the science of asking that question, are we alone?
Yeah, no, good point. Now, one of of course, the big questions we're asking, of course, is the search for life. And what, up till now, obviously, the last 20 years has been quite a renaissance for Mars, or understanding and the prospect for life on Mars. Before Pathfinder, the thinking had been that it was a pretty sterile planet. But since then, a lot of evidence has been discovered, of the prospect of life, evidence that life might be able to exist. You want to kind of go through what some of the evidence has been over the last, several years that we have found that could be indicative of life on the surface, or at least under the surface of Mars?
So, Chris, that's a great question. I mean, we left the Mars of Viking after this brilliant foray into landing dual laboratories powered by radioisotope thermoelectric generators in a search for that direct sign of extant, today's life, right in that soil, that Martian sedimentary layer. And Mars was just not a very welcoming place in that regard. And we learned things that I think we hadn't quite realized. And so Viking gave us, I guess, a bit of a challenge. We thought that maybe Mars was this sterile, world where all the action was in the past. And then thanks to this bold foray of missions, including the Mars Global Surveyor in the late 90s, we ended up changing our equation. We changed the path. Instead of looking directly for living life, microbial life in the soils, because that environment was inhospitable as far as we could tell, we decided to look for signs of ancient life through the rock record by following the water. And that paradigm, searching, seeking, and ultimately returning samples became our paradigm. And that paradigm shift shaped the new Mars exploration program that NASA developed in 2000. So, Chris, what we've learned, in answer to your question, is that Mars is a water planet. It's just that the water doesn't work quite the same way as it does on Earth because of Mars' really topsy-turvy history of climate and environment. Mars goes through massive environmental changes on cycles that we're not familiar with on Earth, and that's why it's such a special model. A lot of the Mars
we are having an earthquake in California right now.
Oh my goodness!
Yeah, we just had a little jostle here. Things shook around a little bit. Now it's settled down, but it was definitely a sharp jolt there.
Geez,
I'm here. I'm okay. I didn't it wasn't bad enough for me to crawl under my desk, but that's it. We'll see what happens next.
Well, Hoppy, you kind of bring up a great point of there's problems here on Earth. How often have we all heard that query of there's problems here on Earth? Why Mars? Why are we doing this? This is really something I'd like to ask because we're not too far away from the launch. It's like we're getting ever closer. So I'd like to pick everybody's brain on this, Chris, including you. Why Mars? Why is this important? Why do we keep sending rovers, and why do we want to put boots on Mars? So whoever wants to go first, I'll let you chime in.
Well, I just like to say one thing, and then I'll turn it to everyone else. Why Mars isn't the question. The question is really why not Mars? Because here we are on a very special, large silicate planet with surface oceans, and we sometimes tend to think of that as the model for everything. And our storyboard on Earth doesn't reflect the way the rest of the universe, the rest of the planets of our size class work. Mars is a perfect test case to probe the aspects of Earth history that reflect why we're here as living things. So why not Mars? And why not use it as that island in space to understand ourselves a lot better? And that's been what Mars has done repeatedly. So our forays with these robots, eventually with women and men, I think is going to open our eyes to that bigger universe in almost a Star Trekian way. So I would say why not, especially when it's the first and only accessible place where that question for the kind of life, that kind of especially microbial life, we come to know is so dominant on Earth, especially in these days. Especially, why not look for that, the signs of that in the record, even the modern record, perhaps in the understory of Mars at Mars? That's the quest. It's curiosity driven.
Wonderful, wonderful. And on that note, it was perfect timing, and we will get back to that question in just a minute, but I want to welcome our sixth guest today, Mike Hecht. How's it going, sir? How are you?
I don't think he's quite there yet.
No? It looked like he was there. Let's try his next one.
Lost him. Oh.
So
wait.
the earthquake was 4.5 in San Fernando Valley, not far from here.
Mike, do we have
I'm glad you're all right, huh?
We're glad you're okay,
yeah,
sir.
we're fine.
Well, while we're waiting for Mike to pop on here, Ashley, why Mars? Why for you?
I really love what Jim said. Why not? I think that there is something that ties all of us humans together, and it definitely is that curiosity, that that thirst, and that hunger for wanting to know more about our origins. And I just think that it's really amazing that not only all of our different industries are coming together, that the U.S. can work with international partners, and we can all, come together, no matter where your origins are, no matter your political affiliation. Space is so incredibly uniting, and I just think it's such a fantastic thing that we can all kind of in this kind of funky climate that we're currently experiencing.
Okay,
we can all come together and be rooting for one thing. Oh, is someone else? Oh, I think Mike's here.
Mike might have just accidentally.
Okay.
Yeah, Mike might have just had his stuff there, so it looks like he might be there, maybe a little bit. I don't think he meant to interrupt, though.
No, it's okay.
Yeah, it looks like he's having troubles. He seems to be.
Yeah.
Hearing again.
So yeah, just to wrap it up, I definitely echo the why not. I think that space is so uniting, and I think it's really exciting that we're going to go to explore, learn a little bit more, and hopefully make Mars the next step in making humans a multi-planetary species.
And Hoppy, we'll go to you next to give us your thoughts on why Mars.
Sure. I mean, to me, it's all about the search for life. I mean, humans have always wondered, are we alone? There's been so much science fiction written about Mars, John Carter of Mars, all of that. If we do discover that microscopic life evolved on Mars early in its history when conditions were the same as Earth, I mean, that would tend to lead us to believe that life could be common in other places in our solar system and other star systems. So, yeah, I think it's a very fundamental question of how hard is it for life to start once the conditions are right for life. It may be that we find life everywhere where the conditions are prime for that. So it's a very fundamental question that I think we need to answer. And if we do discover conclusively that there was life on Mars in the past, I think that would be a revelation for everyone. We would want to understand that life. Is it based on RNA, DNA? How similar is it to life that we have here? It would also enable us to ask the question about how does life transfer? Does it evolve independently on each world? Or is there panspermia where, a meteorite from Mars may have molecules on it or proteins that then were the seed for life on Earth? So those are all fundamental questions that I think are very important to answer. And Mars is the easiest place to get to. I mean, yeah, there may well be life in the oceans of Europa, but that's a harder place to get to with the radiation and just the logistics of getting there. So I think Mars is the easiest place for us to get to, where I think we have a good chance of answering some of these questions.
So, Mike, we may finally have you. Can you hear us, sir? Maybe not. We were hoping. Well, we're about 15 minutes away from the launch now, so it's an exciting time for everyone. So I don't want to keep everybody for too long. I know that everybody probably has other things that they want to do to kind of check on that. We have some other guests coming up in a little bit. So anybody want to share some final words a few minutes out from the launch of, what do you want the world to hear? The world is watching.
Well, Ron, I would just add one thing. It's been a long time, but I think people should understand Perseverance is really a magical extension of ourselves. Its tools for measuring Mars are staggeringly good. I mean, seriously, they border on science fiction. The Mastcam-Z camera system with Jim Bell and his team, I mean, literally inspired by some of the thinking of James Cameron. The RIMFAX radar will be our first way of electromagnetically sounding it at incredible scales into the shallow upper surface of Mars, where there's going to be lurking magic that, seriously, it may be one of the answers to where the water on Mars may provide environments to make things much more interesting. So as we think of Perseverance and we embody her as an extension of ourselves, I think we can all enjoy that ride. I mean, it's going to be a new situational awareness for this planet as we seek to close the loop and bring Mars home to the labs. Hoppy said, search for life. Search for life requires us to use the tools that we use on Earth to search for life. And that means we have to bring the rocks and soils and atmosphere home to Earth to use those tools. We cannot bring them all with us. How many of you have gone on a vacation? And I don't think you brought your living room TV. I mean, maybe you did. Personally, I'm not a good packer. But Perseverance brings us the tools to find the stuff to bring home. And Jezero Crater, what a sight. I mean, we hungered for the sites. And that was one of the harbingers of this Mars program, is finding the right place to go. We're going to the right place. So I'm bullish. This mission is, going to be spectacular, and it's going to extend ourselves to being better Martians. Thanks.
Absolutely, Jim. Dr. Garvin, it was great to have you on today. Actually, we'll go to you next. Any final thoughts or anything you want to share with us as we rapidly approach launch time?
Yeah, absolutely. I think we're about 15 minutes out now. I know that aside from myself, everyone at Aerojet Rocketdyne across the country is just really waiting for the smoke and fire. We're super excited to see the Atlas V launch off the pad. And as excited as we are for the launch today, one thing that we're really jazzed about is going to be the landing in February. Landing on Mars is extremely difficult, and we put years of effort and ingenuity into building these engines that are going to get us to land on the surface of Mars for the 9th time. So as exciting as today is, we're just excited for, the next 7 months, and then for the years that Perseverance is going to be roving the planet after that. Thanks again, Ron.
Of course. Ashley, it's been great to have you. And Hoppy.
Oh yeah, I'm really excited about this. Go Perseverance! I'm really looking forward to this.
Chris, you got any thoughts before? I mean, we're what, 20 minutes? 20 minutes out. Yeah. What do you think? How are you feeling?
Well, I'm feeling pretty good. I mean, this is very exciting, but I may go back and answer your earlier question of why Mars.
Sure.
And the reason I've always looked at this, everything everybody said here, but also I think when people say there are problems here on Earth, well, the way we solve the problems here on Earth is by investing in missions like this, things that are optimistic, things that are ambitious. They will challenge us. The technologies that go into this, the innovations will have benefits here on Earth, the inspiration to students around the world. Think of all the students that get inspired on a daily basis by space exploration, and how these kids, use that motivation, use that inspiration to strive, to achieve in school. And that translates into the betterment of humanity. So I think, particularly at the small with NASA, not just NASA anymore. Of course, this is a big international push we've had. This is actually the 3rd international mission to be launched in the last few weeks. But there's also a lot of investment from commercial entities these days But I don't think people understand also that NASA gets less than half of 1% of the federal budget. And when you think of this small investment that the federal government makes, all this enthusiasm around the world, and how that really does impact our quality of life, our outlook for the future, it is very much worth the investment. And I frankly think it is vital to help solve the problems here on Earth, to invest in projects like this.
Wonderful, wonderful stuff. Well, I know that everybody probably has to go for this one. Chris, you and I can hang out. We've got another guest coming on here in a minute, but we are coming up really quickly on the launch. So thank you so much to Hoppy, Ashley, and Jim for joining us today. Thank you so much, everybody.
Thanks, Ron.
Hey,
Go Mars.
Go Mars. So, Chris, we're not too far out now. It looks like we're going to have another guest coming on here in just a few moments. Hopefully. So we've had a little bit of technical difficulties this morning, but it happens. But I do know that there was something that you wanted to mention. We have a wonderful member of our board who was kind enough to help support us today in this incredible event. So if you'd like to share that with us.
Absolutely. And if you can look up, I have to find the email which she sent also and how she wants us to acknowledge this. But Allison Renault
absolutely
donated $1,000 so we could actually run this webinar. So thank you, Allie. Yeah, very, very much appreciated. It's been very helpful. And Ron, do you have the email just so you can acknowledge how she wants this dedicated, how her donation will be dedicated for this broadcast?
If you can stall for 30 seconds, I will. I went to my email as soon as you mentioned it. I'm just trying to find it.
No problem. We should have had it ready before now. But as we're waiting, I also want to mention that we are also running this campaign called the Why I Persevere campaign. So anybody who hasn't done this, we're asking people to submit their tweets, basically Twitter-length statements, explaining how you may have, if you've had a challenging year, as many people have this year, it's been a very complicated year, how the optimism, the goal of getting to Mars may have helped you overcome the challenges. And basically, with the hashtag Why Persevere, send it in to us, tweet it. We'd love to hear what you have to say. We're getting comments from all around the world. So we would love to hear your comments on this. Because I really think, as I was mentioning earlier, I think missions like this have the power to transcend the challenges and bring people together. It is one of the only issues out there, if you think about it, that has bipartisan support, overall, general support from the public, and international support as well. And so there aren't too many issues right now that, just cross partisan lines and have broad overall support all around the world. And as I mentioned earlier, this, internationally, there's evidence of this. Just, I believe it was last week, the Chinese launched their first mission to Mars. The week before that, the United Arab Emirates sent their first mission, the Hope mission, which will orbit Mars. And when it arrives, it'll help celebrate the 50th anniversary of the formation of the UAE. So, but this isn't it. There's also a couple other missions coming up in 2 years. Europe's going to be sending, in partnership with Russia, their second ExoMars mission. And then shortly thereafter, I believe 2 years after that, India will be sending another one of their missions. So the entire world is engaged and inspired by Mars exploration. And this is really a critical element. While the U.S., we hope, will be able to still take the leadership role in sending humans to Mars, we see this as a huge international collaboration to get there, similar to what the International Space Station is, which is a collaboration between many nations. We hope we'll be able to do that when we go to Mars.
That's great. And so I do have this pulled up, and then we are 5 minutes away from the launch. So we're going to switch over to that. But Allison wanted to dedicate that to the captain of the Afghan robotics team, Fatma, and her deceased father, who gave his life for the education of his daughter. So a wonderful cause and a wonderful team of people. If you don't know the Afghan girls robotics team, please check them out. We have a panel from them last year on the Humans to Mars Summit 2019. You can find it on our YouTube. And Chris, any last thoughts before we switch over to the live feed of the launch? We're 5 minutes out.
Go Perseverance.
That's all we need. So we'll switch over to that here in just one moment.
Nervous and excited.
Yes.
There are a lot of things happening as we get ready to count down to liftoff this morning. We have about 15 seconds left in this hold before we pick up the count.
Yeah, we're going to listen into that. The fifth team, the one we haven't mentioned yet, is the Department of Energy, who is responsible for the MMRTG, the power source for Perseverance.
3, 2, 1, mark.
Awesome. So this is now the terminal countdown. This is that time when things become more and more automated over the next few minutes, and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, the teams are very disciplined, very focused on what they're doing. The operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety, just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now. But again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post liftoff, I want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show. There's a ton more content we have to bring you, and we are far from over. I want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is gone. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
FTS
sequence at T-31 seconds. So that's a big thing that they're getting done here. At T-25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count
1
started.
minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Then valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for. The FTS system, there you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable
venting
at
is the
step 3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check. Go Atlas. Go Centaur. Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5,
5.
4. Engine ignition. 2, 1, 0. Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So that you're seeing live footage.
And we have Mach 1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way.
So, Chris, that was a pretty wonderful launch. You just got to love it whenever we have success like that. We haven't had a whole lot of successes in the year 2020. We needed one, and when the name of the rover was Mars 2020.
I don't want to still a long way to go. A lot of still a lot of course corrections, other things. 6-month voyage, then it has to land. So, but very, very impressive launch. So, congratulations to NASA, the international team, everybody. Let's just hope this mission continues like it just has, like the launch just went.
Well, and we do want to remind everybody that we're going to still stick around for a little while, give you some more of the updates that are going on. We've got plenty more guests. We're going to be here for exactly 1 more hour. So we're going to give away that Humans to Mars, the virtual Humans to Mars Summit registration here in a little bit. And we do want to remind you, if you've never seen one of these very cool things, this is a MOVA globe. And it's kind of funny that the green in it is making the green screen effect kind of work a little weird. But we're giving away one of those too on Explore Mars on our Facebook and on Facebook on Stardom at Stardom Space and Explore Mars at exploremars.org. So make sure you check that out. We have more amazing guests coming on. We got Karina Perez from AIA coming on in just a few moments, and that Christina Alvera will be on in a little bit, and Lee Giat, who is about to become an analog astronaut, a Mars analog astronaut, actually. So we're really excited for that. So, Chris, what's next for Perseverance? So obviously it's got a little bit of a ride, but once it gets there, that the now infamous 7 minutes of terror.
Yeah, no, I mean it truly is. There's a good reason for the name 7 minutes of terror, because literally it's going from 13,000 miles per hour to 0 in 7 minutes, and it's just a really remarkable process. And I apologize if I make any mistakes with the process, but as it's entering, with the heat shield, then it has descent rockets to go off, then parachutes, then descent rockets again, and then of course it has that retro rocket pack, whereas the sky crane lowers it down to the ground. And then it breaks away, the retro rocket flies off and crashes at a different location. But think of all the engineering challenges, everything that needs to go right for that to happen. And remember, Mars is so far away, this isn't being actually managed by the people on the ground. This is all autonomous because we do not have instantaneous communication with Mars. So it really is a testament to the amazing engineering that actually went into it back in 2012 when the Curiosity rover landed. But it also highlights the challenges of when we send humans to Mars. We won't be able to do it this way. We won't be able to use a sky crane. And of course, we won't be using airbags like we used with Spirit and Opportunity, as well as the Pathfinder mission. We're going to have to drop at least 20 metric tons on the surface of Mars when we land humans. And this Curiosity and Perseverance are just 1 metric ton. So a lot of big challenges coming up. And it's it's probably considered the biggest challenge for sending humans to Mars, figuring out how you can land, at least 20, probably 20 to 40 metric tons on the surface of Mars. And then, of course, get people back. But going back to the original question, yeah, long mission to go, but it's certainly comforting to know that we've done this before, meeting this mission profile, and that all these systems have worked in the past.
And so I think that this is space has been the big thing for this year, and we've been really fortunate that we've seen the first launch from of humans from U.S. soil U.S. technology, U.S. astronauts just happened. They're getting ready to come home, right?
Yep, Sunday, I believe.
Yes, Sunday. So like we've got a whole lot going on right now, and it's just a really, really exciting time. So I mean, what is it about space that just kind of keeps us going in tough times like this? Because we've seen this before. We've seen this during the space race.
Well, we did. I mean, think of how when the Apollo landing happened, and in July 1969, this was a very complicated time period in U.S. history. Yeah, it was right in the middle of the Cold War, at the height of the Cold War, but there was civil unrest going on, the civil rights movement, anti-war protests, a whole bunch of other elements in society, and it was a challenging time. But in the middle of all of that, in Vietnam happening, in the middle of all of that, the world came together, and including Russia. Everybody came together as Neil Armstrong and Buzz Aldrin landed on the surface of the moon. And of course, there were, another 5 missions after that successfully landed. Apollo 13 did not, of course, but that's another story. But it has a wonderful capacity of bringing people together. And as I mentioned earlier, it still is. I think even more now. I think the world and the country is even more united towards space exploration than we were back then. If you look at the polling, if you look at the overall support we've been getting, within Congress, from both sides of Congress, both parties, when you do have the general polling of just regular people, particularly when they understand the benefits and the budgetary realities, there's overwhelming support. And I think that's very exciting. And I think it just has that power to inspire and transcend challenging times, and can help lead us out of these challenging times. But as you were alluding to earlier, as we prepare for the commercial crew vehicle to return on Sunday rather, we are in a better position than we've ever been to really start an age of human exploration, certainly since the Apollo program. But I think we're actually in a much better position now than we were then also. The Apollo program was wonderful, but it had one single goal with one single, at least political reason for achieving that. The one reason was beat the Soviet Union to the moon. All right, we beat the Soviet Union to the moon, but then we didn't have any justification for continuing. And so the Apollo program was shut down. We had years of we were off astray, not really doing much with human exploration. And then we got the shuttle program, and we've slowly been building back. But right now, think of everything that's going on with all these Mars missions, robotic missions. We have the commercial crew program. So now the United States is finally launching people back into space. We are gearing up to return humans to the moon in preparations for sending humans back to Mars. You have this massive interest in the commercial sector, not just commercial crew, but all of these companies that are building launch capacity, and not just launch vehicles, looking at space hotels, but also working on all these systems that are vital to it. Companies in Silicon Valley working on artificial intelligence, other companies looking at how you can grow food in space. And all of these capabilities will also have benefits here on Earth. So I think we have there's a lot of stuff here that you should be optimistic about. Who knows what the future will bring, but it is really exciting with everything going on in space exploration here in the United States and all around the world. The number of new space agencies that have been international space agencies that have been created over the last few years is really quite striking. Countries, small countries you never would imagine could have had a space program before, now can have a space program. And I think we've seen even high schools and middle schools are now able to have space programs with CubeSats. So we are living in a different age than we did even just 10 years ago.
Agreed. And I know you just said a lot, so I know it's weird to just say agreed, but I was paying attention. We have two more of our guests that are joining us right now. So I want to welcome them on. I don't want to keep them waiting too long. We have Karina Perez from AIA, and then Sky Schwartz, who is at Kennedy Space Center. So first up, I want to go to Sky first, just because she's only got a few minutes. she's one of the few people that actually got to see the launch. Like, she works there, so she had a pretty good view of it. She did some pictures, videos. So tell us a little bit about it. And it looks like your face is frozen right now in a smile. So you're either really happy about the launch or your face is frozen.
And there's a lot of control. Yeah.
A lot of control.
I'm walking more towards the Wi-Fi. Hopefully that works. No, it was really incredible to see. This was the first Mars launch that I've seen in person. You know, I've seen a lot of SpaceX launches and things like that, but remembering when this first got started and when they first even announced it way back in the day, and actually getting to see it launch from only like 6-7 miles away was absolutely incredible. It really just shows, you know, how amazing and how much technology is really improving, and that we're actually sending, you know, essentially Curiosity's sister to Mars. And it's really cool because I'm really excited to see what we're going to discover and what new things we're going to find out.
Well, Sky, I know you got to go back to work, but tell us what you're most excited about for the mission before you head back in to teach the kids.
We don't have teaching kids. It's a production right now.
Oh, production. Well, that's right. You don't actually have kids. You're not allowed to have kids around. So yeah.
Yeah, exactly. I'm really excited to see what we find, you know, because there's so many different things that can happen. There's so many different discoveries that can, you know, basically come to life. So I'm just really excited most of all to see, you know, basically get down to the nitty gritty and actually see what's discovered a part of the Mars 2020 and Perseverance.
Awesome. Sky, we're glad to have you on for just a few moments. And we're going to share a couple of her pictures and videos that I think you took with your phone, right? A little bit later.
Yeah, I with my phone.
Nice. Yeah. Well, it's always good to see you, Sky.
Me. I really appreciate it. Sorry, it can only be like 2 seconds.
Of course, you got to go back to work. We completely understand. We'll see you soon.
Bye.
Bye. Bye. Karina, how are you doing this morning? How are you feeling after the launch? I know that you get as jazzed and nerdy as me when it comes to these things. So it's the reason why we became such fast friends. So do you give it a thumbs up?
Yeah, 100% thumbs up. It was great. And actually being able to see it. I wish I was down there. I really wish I could have gone, but obviously, you know, some issues with COVID, so couldn't go down there. The last Mars launch I went to was InSight, but unfortunately in the middle of that, there was a lot of fog, so we weren't able to see it. So it was nice to actually see it, and I'm very excited for more Mars launches and getting to explore and, in a way, you know, prepare for possible human exploration. That's what we have our robotic friends for, to bring back all the scientific data and also help us prepare to keep exploring and keep going. So super excited. I've been awake, I think, since 6. Because it's 8 a.m. right now where I am, and I know, Ron, you've been awake basically all night. Chris, I know you've been awake all night. I think I woke up halfway, like through the middle of the night, and I looked on Twitter and I just saw Chris's face. And I was
like, well, there was what
magic of recording.
Yeah. So the way that we started the stream was, and for people that don't know, we have been doing some really great events all through the spring and into the summer. So we've been doing our web series event. So if you haven't checked it out, please do. You can check them out on YouTube, and we have them constantly. But we're so we had the Life on Mars conversation that we had. That was actually the very first one we did as soon as COVID kind of started happening, with Jim Green from Dr. Jim Green from NASA, and and Penny Boston as well. And I believe she's a doctor as well. I'm sure she is. She's brilliant. We didn't really talk. I was just backstage, so her and I had not yet met and spoke to each other yet. But she's wonderful. And they talked about life on Mars, and we also had the Perseverance panel that we had running earlier this morning. So if you all haven't seen that yet, please go and check it out. It's basically, you know, a breakdown of what we saw happen today and what we're going to see in the next few weeks. So Karina, you're at AIA. Tell us a little bit about the organization first.
Yeah, so I'm with the Aerospace Industries Association, a lot of SS, and what we do is we represent the aerospace and defense industry with governments, and that being the executive branch with Congress, and so we work with everyone really, and also to the general public, and that's where my work really lies, is trying to get the general public, outside of the people who are already excited about space and science and innovation, to be excited about what we do. So as you all know, especially if you're watching this, is that we love space, and we know how important it is and how much it can bring to humanity. And so part of my job and my team's job at AIA is to help everyone else understand what our industry does and what it can do. So I love my job, and I get to learn from experts, and I get to learn about like everything happening. But then I also get to have the fun job of taking all of that, packaging it, and saying, "Hey, world, look at how cool this is." I know you think it's a little nerdy, and yes, it is, but it's so cool.
That's fun. Oh, well, I can't wait till we get to the point where it's like, I know we think it's a little nerdy. Like, no, it's fine that it's nerdy. That's the things we should celebrate. You know, it's like we've had reality TV stars for 20 or 30 years now, and we're no better for it. You know, other than the occasional like really cool show, Anthony Bourdain, we miss you. But you know, I think there's a lot there that it would serve us well to have more people that were nerds on TV talking about space. And I know it's something that we've had at the Humans to Mars Summit. You know, more than a few times. That was actually the very first panel. That's how I've met everybody and ended up where I'm at now. So, you know, AIA, you're talking about, you know, kind of reaching out to the general public. When it comes to Mars, how are you all working to kind of get people excited? Although we got to say, you know, NASA and JPL and, you know, everybody's really done a great job for this one.
Yeah, so what we're trying to do is reach more of the already existing tech crowd and things like that. So we've gone to places like South by Southwest and CES. So places where you would see some of our presence, but not really a lot. So we've gone there and really talked to people about what it is that we do. And so that's how we've been approaching it. And also for the young kids, we're approaching it in a different way with our rocket contest. We have the world's largest rocketry contest, and it's for students in grades 6 through 12. We have about 5,000 students participate each year. And this year, because of COVID, unfortunately, we couldn't have the physical competition. But what we did is we partner with Kerbal Space Program, the video game, which I know a lot of people have probably played.
Yes.
I know, it's so much fun. It was one of
the second one's coming out, right? Are we getting ready to get a second? Oh, yeah, okay. Sorry, go ahead.
I
did it out real quick.
Getting to play Kerbal Space Program for work was amazing, by the way. Just, yes, I'm loading up this for work. Yes, I'm going to launch these rockets.
We've done the same thing at Discovery Center. We have Minecraft on some computers that kids can you know, use during the summers. You know, not obviously so much recently, you know, because it's like with social distancing that we have at the Discovery Center. But nonetheless, it's still one of the things. Like, oh man, I just want to go play it and kind of test it out a little bit. But but yeah, so you're using Kerbal for this competition.
Yeah, and right now we have over 1,200 kids participating for the summer. So around August, they'll be giving us their saved files where they will show us how they got to the moon. So, you know, first get to the moon, then eventually to Mars. And so they're going to show us how they got to the moon. And their main thing is to stay under budget, which I feel like anyone in industry watching this would get the importance of staying under budget. So they have
absolutely
they have a 250,000 budget, which in game it's very different than real world. But they are super excited, and as soon as we announced it, all the kids were just like, "Oh my god, I can't believe we get to play video games!" And we're like, "I know, we love it too." So super excited about that, and hopefully we get to continue next year and be able to provide more missions, because you know Kerbal itself has a lot of missions with NASA and with ESA, so hopefully we can, you know, work together with them and down the line. But for now, we're really grateful that they're giving us these free copies for the students so that they can maintain engaged through the summer and, you know, be involved in launching rockets. And another fun thing that I've been working on is launching a diversity in STEM calendar so that we can ensure that we have diverse voices as we move forward into the galaxy. We need everyone, but we can't get everyone if they don't see themselves in our industry. So we created this 2020-2021 calendar STEM activities and highlights. And so it's highlighting really diverse people in our industry and giving these students the opportunity to see themselves in it. And to some of the schools which that are getting these calendars, they also got books about diverse people in STEM. So we've been really trying to not just tell the general public and tell tech people about like come to our industry, but also telling the young kids like, look, there's so much to do here, and you can really see yourselves in here. And here are people who look like you, who have fitted here and who have opened the doors for you. You just need to come on in and work hard and have fun ideas. So again, I really like my job because I get to do all these fun things and tell kids, come on, let's go on to Mars and let's go explore.
I have myself. You didn't mean to. I love that. I think things have changed so much. When I was a kid, not like that, but when I was a kid, I got yelled at because I had Mortal Kombat and I didn't tell my mom what it was, and she didn't know there was a rating system yet. It's like, what did you just do to that young man there? I'm like, well, that's you all know you played Mortal Kombat, right?
Yeah.
But it's a little bit different now. We can learn so much about it, and it's such a great tool, and we've got more than a few people that are talking about it through the different comments on social media. It's such a great way to be able to get people invested. Now, playing video games can give you a real skill set. That's how so many people are on computers, and if you would have told that to my mom forever ago, she would have laughed and said you're probably right, but she would have given me a little bit of grief about it too. So yeah, I think it's really exciting what you all are doing. And Chris, any questions that you want to throw in and discuss a little bit about?
Yeah, actually, as you mentioned, I mentioned earlier before you came on, there's a lot of public support, generally speaking. But since you are engaging with the public in different sectors of the public, what do you think the biggest challenges are and some of the most optimistic things are in your engagement with the general public, and to show why this is important, and make sure that they realize in many ways they can participate? I don't think a lot of people understand there are so many different ways the general public can actually participate in these missions.
Yeah, so I think one of the biggest things is that, well, it's everyone really likes NASA. They like space. They don't really know what is currently happening, or what technologies are being developed, or what things. I mean, just in general, there's not an insight into really what is happening. Like, a lot of people don't know that we have had astronauts constantly in orbit. So that is one of the biggest challenges, is being able to tell people like, this is everything that's happening, and it's a lot happening. So it's just trying to tell them exactly like, this is what's happening, and look, you fit in here, you fit in here. So that's one of the difficult parts, is really like being able to bring all these incredible, amazing things and package them down to say like, look, all of this is currently ongoing. But one of the things and also the fact that they can participate with citizen science and all the projects that are available, and how they can be involved, and even from a young age. So I think there's a lack of insight into what they can do. And so that is one of the biggest challenges. But the most rewarding is that once they know, they're just like, how do I get involved? What do I do? Like, what is happening? Like, even like small companies who create things that might be not even think that they're space applicable, once they learn, they're like, oh, wait, there's a applicability of what I do in space. And it's like, yes, there's applicability of everything in the world in space. We need everything to move with us.
I mean, some wonderful points. And so just before I get back to that, I just want to welcome Eddie Gonzalez. Eddie, what's going on? Eddie's in the house. So what I love about this is we always get really lucky that we have our friends from past events like Karina and Eddie. Eddie has only so far been to our virtual summit, but we had invited him to our virtual panels. He was going to come and see us at the virtual or the real summit this year. If I can get it right, one of these days I'll get it right. I really slept 45 minutes since yesterday, guys. It's just, I was excited about it, and I knew that I had a lot to do today. So, but Eddie, it's great to have you on and say hello to you. But Karina, wonderful points to what you were sharing. Thank you so much for sharing your point of view. And stick around. I'm not saying, to go. But Eddie, how are you doing this morning, man?
Go get coffee.
Go get coffee. I'm going to have to in between this stream and the next one. Once we do the giveaway, we got to do the giveaway first. Eddie, you're at NASA. You guys had a pretty freaking good morning. How are you feeling, man?
Man, I'm doing great. And I think it's pretty cool that the people in California had a virtual alarm. The Earth woke everybody up and said, get up and watch this launch. I think that's cool.
Well, the funny part is that we had Hoppy Price on from JPL, and he was just like, whoa, and we're like, oh, what happened? And we was like, what are you talking about? He's like, we just had an earthquake. So yeah, that's kind of a nice thing to do. Just kind of give him a little nudge.
It's funny, it's the first earthquake on one of our broadcasts, so something to remember.
Yes.
So, Eddie, you do a lot of work with a lot of people in a lot of different communities, and space is so important to you. What was the big thing about today that one excites you, and what do you think it's going? What about it do you think is going to excite the communities that you reach out to?
Again, it's just about hope. I really love the diversity that's on the Mars team. One person that just comes to mind right now is Luis Dominguez, and he's at KSC right now. He's from JPL. I mean, again, I could go on and list hundreds and hundreds of people. Dr. Adam S., he's incredible, and he's doing a lot of great work. And I consider him Mr. Mars anyway. But to see this go off and to see such young scientists and engineers on this team, it gives me hope for the next generation. And I look forward to finding them as I do presentations and virtual panels and things like that, and introducing them and letting them know that they too can work in the aerospace industry. I mean, hopefully we can bring them to NASA, but if they're at SpaceX or any of these other amazing companies, then so be it.
Well, let's talk a little bit about that. So for people that don't know who Eddie Gonzalez is, that's a shame that you don't. And I was introduced to Eddie not too long ago, actually, from one of my favorite astronomers. She was talking about the great work that he does. And I was like, this guy's amazing. I got to talk to him. Got to be friends with him. And he makes some great Jeff Epstein jokes. So Eddie, can you tell us a little bit about what it is that you do at NASA and how you really kind of connect worlds together?
Oh, thank you for not asking me about Jeff Epstein. That's hilarious. Yeah, what it is that I do. So like, for example, yesterday I was on a panel for natives at NASA. So all of the various Native Americans that are at NASA, I did a soft skills presentation for them. Just basic things like, what do you do with a business card? So I think it's very important if you're getting a business card, and this is also professional advice, don't get it and put it in your pocket and don't reach out to somebody right away. I think you use that, turn the card over and write some bullets about the conversation. So when you do reach out, you can remember some of the things that you talked about, whether it's for an intern or for a project or something that you're going to co-author or something. It's important when you reach back, they're going to say, wow, this person really did remember me and this is awesome. And that's how you start your network that will eventually hopefully turn into relationships.
And, Eddie, I know one thing that you talk about, and you particularly did in the diversity panel was, this wasn't a path you expected to end up on. It was tough going when you were younger. You were on a little bit of a different path, and then you ended up, at NASA doing the great things you do. So I think it's a wonderful story. Can you share a little bit about how you got to where you are?
Yeah, sure. First, let me kind of start backwards. I've been at NASA now for 20 years. I worked at the Jet Propulsion Laboratory for probably about 16 years off and on. In between that, I did a detail at NASA headquarters. A few years after that, I did a fellowship at NASA headquarters under MURAP, which represents minorities and diversity, which I loved doing that detail. So shout out to Dr. Joletta Patrick for that. And now I'm at NASA Goddard working in heliophysics under Dr. C. Alex Young, who's an amazing scientist there at NASA Goddard. And now to tell you a little bit more about my story, and I'll be brief. My father passed away on Christmas Day when I was 12, 8 days before my 13th birthday. And at that point, I knew I was going to have to hustle and grind because the cavalry wasn't coming. So I always had a good mindset and a good, a good drive to do well. Unfortunately, that was derailed a little bit by teenage mistakes, barely graduated from high school. And let's just say that I made my way into the professional world working at a law firm. Started in the mailroom, worked my way up to senior staff, and then a position opened up at the Jet Propulsion Laboratory that was perfect for me on the business side. But as soon as I got there, I recognized that there was a little bit of a lack of diversity, and I wanted to participate and work in the education side and see if I could help change that. And along with an amazing team over at the Jet Propulsion Laboratory, we were able to do that. And I continue to do that today, but I do it over at Goddard now.
I love it, Chris. You wanna pick Eddie's brain a little bit?
In your work with underserved communities, what sort of programs are there to reach various communities to show not only what NASA and the space community is doing, but how they can actually participate?
That's a great question. See, a lot of interns or a lot of students that are looking to get into NASA, this is what they typically do. They'll go to nasa.gov, type in interns, and then you'll see a list of internships throughout the various agencies across the nation. But what they don't know, and what I try to share with them if I go to national conference, is that each NASA center has their own website, and they have their own internship programs. So there's actually 11 doors you can go through in addition to the nasa.gov, or creating a pathway profile, or a profile in USA.gov. So there's a lot of different ways that you could get your way into NASA. The other thing you can do too is, I'm a contractor and I have a contract agency that I work for called AdNet, and they're great. So check out which center is hosting contractors and what companies those are, and reach out to them as well. And again, you just double, triple, and quadruple your chances of getting an internship or employment if you've got what it takes to work for NASA.
No, very cool. Now, do you mostly work with young professionals, or do you actually deal with students as well, younger students?
The whole gamut. If anybody needs help, regardless of who you are, where you come from, I absolutely have an open door. If you reach out to me, I may not get to you right away. I sometimes get 100 to 200 emails a day. But if you're persistent, I'll absolutely help you. I'll look at your resume. I'll help you with interview tips. And again, I can't promise you an internship or a job or anything, but I can help you stand out. And that's what I really enjoy doing. And also give you the motivation that you can do it. You can.
No, very cool. Well, first off, just a quick question for Ron. Did we lose Ron? Oh,
nope.
Yep, there he is, because he disappeared for a second there.
Well, there was a technical social media problem, but I can produce the show without being on it.
All right, no, I wasn't sure. I wasn't sure if I
cool?
have to continue running the show or not. I have one more question for Eddie, just going back to just a recent launch. Making it sound like it happened days ago. The launch, what was it, half an hour ago? What are you most excited about concerning the Perseverance mission?
To go back to that feeling that I had when Curiosity landed. So I'll tell you a really quick story. I was at JPL. I was just outside Mission Control in a conference room hosting VIPs that were there to watch the landing of Curiosity. Let me share this with you. At 10:30 Pacific time, we knew that the spacecraft was on the ground. Whether it was alive or not, that we didn't know. So at 10:35, everybody in the audience was getting really excited, but me. I was feeling pretty nauseated and thinking, my goodness, if this thing didn't land correctly, I'm going to throw up right now in front of everybody. So at 10:37, when we got the signal that it actually landed, and then a few minutes after that, we got the first image back, that feeling I cannot even describe. I mean, the birth of my first child, anything like that. This was just an amazing feeling, and I can't wait to capture that feeling when Perseverance is on the Mars surface.
Yeah, no, I remember that. I remember the video from JPL. Just electric. I was at a Planetary Society event in Pasadena, which was really exciting as well, with about 2,000 of my best friends there. And
yes.
It was really an amazing time. But yeah, you're right. I mean, since there's such a time delay, and you're right that, we knew it had landed. We just were hoping that we didn't have a new crater on Mars called Curiosity. Thankfully.
Right, correct.
Yes. Hey, right, Ron, you have follow-on questions?
No, I mean, honestly, Eddie, I know that you got some other stuff that you had to hop onto and other calls, so I'm glad that you were able to jump on with us for a few minutes. We got our next guest coming up, but thanks for sharing what you do always, and for being involved with us and coming on our diversity panel. And we really look forward to some of the different organizations that we can work with you and bring them all to Mars with us.
Thanks for inviting. And Ron, by the way, you look great, man. You do. You do not look like you didn't sleep.
Yeah, I love this, man. I mean, there's been plenty of times where I've done a job where I had to stay up all night and just hated it. But, it's like I ran all day yesterday. It was just a whirlwind of trying to get like the last minute things to put this together in the next live stream I'm doing. So I'm going from this one to another 3-hour live stream.
I hope you get some sleep soon, Ron. Chris, it was great to meet you.
Yeah. Thanks for coming on.
Eddie, we appreciate you, man.
You got it. Take care.
See you soon. So, I mean, it's been a really, really exciting morning. And here in just a little bit, we are going to give away that Humans to Mars virtual. And so we've got a couple people chiming in. We got Imran, who was talking about how brilliant it is. Our friend Ashley Carter saying hello this morning. Always good to see you, Ashley, an educator teaching kids, doing amazing things. We got the one and only Bailey Burns, an engineer girl herself. And, you know, one of our favorite people, Adrian, who is one of the volunteers for us at Explore Mars. So, Chris, it's been an awesome morning so far. We've only got about a half an hour left. We got a couple more guests that we're going to say hi to. But, you know, so when it comes to launches like this, a million different things can go wrong. And we've heard the horror stories of it before. Obviously, I think it's only 35% of the Mars missions overall have been successful, or somewhere around that number. I think, right?
It's steadily increasing, and U.S.
It's increasing now. Yes,
a much higher level of success.
But I mean, so many things can go wrong, and I know that you've worked with. You know,
do what? I'm sorry, I don't want to jinx anything.
No. I completely understand. We all wanted to go right.
That, you know, something went haywire.
See, what had happened was, so
and I'll be blamed.
Tony's going to yell at you. They're going to come to you at the event. It's going to be during a Q&A, and nobody's going to actually ask any questions. Just be like, "We saw that live stream, Carberry." But I mean, you've worked with so many professionals in the industry, you know, and so many things can go wrong. So I know that you probably heard some stories about that and what they had to do to make sure that things went right in the future. So what kind of testing really goes into something like this to make sure these things work? Because I mean, I don't think people really get it. And I know that you've probably heard some stories.
Well, yeah, I mean, I think part of it is, since there's so many people working on it, making sure, you know, there's good communication. I think, you know, one of the most famous non-successful Mars missions back in 1999, I think we all famously recall, you know, the mission that didn't succeed because there was confusion between metric and English units. And so these things are important. You know, you have to make sure that everybody, you know, the contractors, NASA, everybody are using the same playbook, you know, as you're putting your mission together. So think of how many people, you know, when we go to Mars, that's just much even bigger. Think how many people have to work together, have to use the same blueprints, use the same systems, communicate to make sure everything works, all systems integrate. This is a really daunting challenge. I mean, for something like a Mars mission like the one that went today, it's really complicated. But as we start preparing, going back to the moon, going on to Mars, there are so many challenges. And, you know, I think it's great to see when teams can come together. And often these days, it's international teams. I think the space station has been a great model. You know, it's also been a model of what not to do, you know, as you know, we started learning how to work together in space. I think there were things that people that were involved with it would have liked to have done a little bit different, but it was part of the learning curve. And so I think this is all building to getting to Mars, as we're learning not only how to engineer, but also learning how to work with each other, and work with each other in at times when you know, sometimes there are challenging international relations. I mean, I'm kind of getting a little off the question that you asked, but, you know, I think I've seen space as one of these great diplomatic tools, one of these things that can hold us together, all during kind of rocky time periods when we've had, you know, not necessarily the greatest relationship, you know, on the public stage. Sometimes with some countries, Russia or others, we've been working together in space, and it's held us together. And we still work extremely well on the space station with our Russian partners, with other partners. And I think that's something that people don't really understand, what a dramatic role the space program, space exploration has in diplomacy, and just a shining light. And people, you know, around the world who have wonderful space programs of their own, even when people are at, you know, see the U.S. foreign policy or other things at a lower point, are not enthusiastic about other things, still see NASA as their space agency, the world's space agency. And I think that still stands true. I think while there's a lot of other competition, and that's great, I think people still look to NASA and NASA's partners. And those partners are growing quite a bit these days, to lead the way that are going to lead us to, to humans on Mars and long-term settlement and working in space.
Well, that was actually going to be the question. I mean, who are we? We're exploring Mars, and what's the goal? Human exploration of Mars, humans on Mars. So
sustainability on Mars, not just exploration.
Oh, fair enough. That's our new tagline. It's just not as catchy, is it?
Yeah, first things first. Yeah, we try, explore Mars. Try as not to get too far ahead of ourselves. Our primary goal is to get there. Figure out if we can live on Mars. And this is what is a shame, because we were supposed to have Mike Hecht on earlier, but he couldn't come on because of technical difficulties. Mm-hmm. Mike is the principal investigator of MOXIE, which is going to be the first ISRU in situ resource utilization experiment. Basically, experiment to live off the land, utilizing the atmosphere. And this is going to be one of these vital technologies because to sustainability. We want when we send people to Mars, the initial missions, it's not only to do the science, figure out if there was life on Mars, but probably the central other question will be, can there be life on Mars? Can there be human life on Mars? And how challenging it will be. Can humans really live on Mars sustainably? And that's not just living on Mars. If you're getting all your supplies from Earth, that's not sustainable. Can we actually live off the land? Can we utilize the atmosphere if we bring in, to make, oxygen, water, methane, fuel? Some of that you'd need to bring your hydrogen with you. But also, can you utilize the water on Mars? There's a lot of water on Mars in the regolith and subsurface water. Can we access that? Can we grow crops on Mars to sustain humans? And if so, how well will they grow? Are there toxins on Mars that, will be obviously harmful to humans, but might get absorbed into the food that we grow? These are all the questions we want to find out early on, because these are the key questions of, can we have long-term settlements? Can we have colonies? Can we live and work in space in general? And this is the ultimate goal. But this is how we as Explore Mars have approached it. Trying to achieve the primary goal first. We're not going to answer any of these questions until we're actually there. We see wonderful conferences, wonderful videos, lots of aspirational speeches about, millions of people on Mars. And I hope that happens. But before we get there, we do have to answer these very rudimentary questions. Can we live on Mars? We think we can, but since we've never been there, we don't know.
You made an excellent point. Like, we hope that we live on Mars, and somebody who might want to be a Martian someday, just like me, Ana Cristina Olvera. I didn't say it the right way. Ana Cristina Olvera. There we go. I always have to say it with the oomph that she taught me how to give a name. So, Ana, how are you doing this morning? Thanks for joining us.
I'm doing great, Ron. Just saw this amazing launch and I'm super excited and hoping to see all this science that you are mentioning. I think we have now 3 amazing missions going to Mars, and I think the science that we're going to get from them, it's going to be so great, and I can't wait for them to get there in February.
It's if you think about it, the world's going to Mars. There's not really a language that the majority of the world doesn't speak that doesn't have something that's going to bring science and that world back to them. And I think it's incredible, So that's actually something that's great to talk about with both of you. UAE's got a mission on the way. China has a mission on the way. All in the last few weeks. ESA was going to have one as well, and there were some technical difficulties there. COVID happened. There were some other things that were going on, but we could have had 4 like all here together. That would have been incredible. Again, the world is on its way to Mars. So, Chris, Anna.
Yeah, no, you're right. And even without the ESA mission this year, 3 missions going to Mars in 3 weeks. Never happened. I don't think people understand how historic this is. We have never had anything close to this in the history of humanity. And I think that is just inspiring. And we should, as once again, getting back to the why question that you brought up earlier, I think this is a good question people should ask themselves when they ask, should the U.S. be doing this? Well, why is everybody else doing it? Why is the world embracing this? I think everybody's beginning to understand the value in exploration, understanding the science, whether humans can actually live on another planet. Can we utilize the resources? But they're also understanding the extraordinary positive impact that such missions have on their countries. I mean, because it truly is. Some of it's tangible, some of it's intangible, but it's real. And it has a positive effect on our outlook on the future. And I believe it has a positive impact on overall economic, even overall economy of the world, and basically how quality of life as well. So I think everybody's beginning to understand this, and this is why not just with these Mars missions. If you look around at, as I mentioned earlier, how many countries are now engaged in space exploration, it's just remarkable. I mean, just dozens and dozens and dozens of countries around the world now have space programs.
Speaking of which, Anna, you worked for the Mexican Space Agency for a little while and did some awesome work. So you want to talk a little bit about what you did and your work as a communicator and kind of getting out what it is that the agency does.
I did. I was the director of press and public affairs for the Mexican Space Agency, and actually we are going to celebrate in a few days the 10 years of the creation of the Mexican Space Agency, which is quite exciting because, having a space agency is very important. We just saw it with the UAE, how they needed to form their space agency for them to really crystallize all these efforts, and now trying to turn from a country that sustain itself from oil to a country that does very complex technological and scientific things, and that's the way they are kind of demonstrating. They want to change their view and how they see their country. So that's the same thing that we're trying to do in some of our countries. Mexico is one of them. So we formed our Mexican Space Agency 10 years ago. And I think, of course, we have many other priorities, and people think that countries like Mexico shouldn't have a space agency. And of course, our efforts are small, but I think it's very, very important to have a representation within the nations in the space sector. So that was my job, to communicate and to kind of invent from a zero point the space communications of Mexico, which was very, very exciting. And I think we have now a strong voice and very interesting and important projects. And I hope I can see more of them in the early years.
Congratulations on 10 years of the Mexican space program. And I was very impressed. I was at IAC in Guadalajara back whenever that was, a few years ago.
Yeah, 2016.
Yeah, that was a really impressive event. But one other thing that I've been impressed at, just the overall passion that we've seen coming from Mexico on space exploration. I know that on a number of these big events, whether it be World Space Week or others, I've seen numbers that, Mexico has had, in many cases, far, far more viewing events, activities than the U.S. during these big space events. And the level of passion is infectious. So I don't think anybody's saying why should Mexico have a space program. I think it's one of the most positive things when Mexico and other countries can have space programs. As I mentioned earlier, it's really democratized, where it's not just, it's much more accessible. Obviously just a few decades ago, we could only big superpowers, I mean, it was so expensive. But now when you have high schools and middle schools that are actually sending CubeSats into space, and every country is pretty much able to do something really exciting, I think that's really positive. I think it was not once again, coming back to sustainability, it was not a sustainable path when it was only just the domain of only 2 countries that could get into space. Well, that's not sustainable. That's a monopoly, and it was, we really wasn't going to lead us to that that future of humanity exploring space together that we hope to achieve.
And so I know we were talking about a little bit about different countries, launching and getting into space. Lee Giat has just joined us, the Astro director himself, and he's really kind of mad at Tom Cruise right now because Tom Cruise is trying to make the first movie in space, and that is Lee's goal, and Lee's going to do it. So
Actually,
Lee said
there has been a movie made in space before.
He wants to make a full-length film. He wants to make a full-length
feature film. Not a feature film.
Not a feature film, exactly. I told him that we were on Drinks with Explore Mars, and I didn't realize that Richard had done a film in space, and I was like, oh no, I didn't know. I don't mean to ruin your dream, but it happened. He's like, no, that counts. It's a short. I want to do a feature-length film. So now you're gonna have to do the first good one. But Lee is not saying Richards. I meant like the Tom Cruise thing. Just being silly.
Yeah.
But
first original one, because we already know it's going to be Mission Impossible.
I've heard that it's not going to be Mission Impossible. I don't want to go too far off.
But it's not Mission Impossible, but it's Mission Impossible.
It's Mission Impossible. Wait, hold on a second. Anna, what was on your cup just now? What was on your coffee cup? Nice. Well done. I've seen it everywhere, but I've not seen it on a coffee cup. See, that was just well played. That's the reason why we invite awesome people like Anna on.
I have world's okayest brother.
I've got mine that's in the kitchen right now that I could grab, but it's got some language on it that Neil deGrasse Tyson never used, but people have used in a meme, and you probably have one of your friends tag you in that picture where it says y'all need science, and that's what it says on my coffee cup, so I can't wear it on the show. But Lee, we're glad to have you on this morning. You're getting ready to do a Mars analog astronaut program, I understand. Is that right?
Yeah.
Well, give us some details, man.
Yeah, so it was supposed to be in November. We don't know if that's going to happen just because of the world right now. But basically, we're also kind of figuring out where it's going to be. It was set to be MDRS, but there's still stuff going on that I can't really talk about. Basically, the plan is to conduct a large-scale multi-habitat mission and start building on that. So my role in that, having a background in filmmaking and astronomy, is to figure out how realistic is it, and how, in isolation and in very small crew sizes can we bring the film industry to space and to Mars. So I will be making a movie on Mars when that happens. So it'll probably be, I think, early next year is when we can expect it to happen. It'll be like a 2 to 3 week mission where I'll be living in isolation with my film crew, and we're going to write, shoot, and edit a movie on Mars. And we're going to see, obviously there's things we can't test, like Mars has only a third of the gravity that Earth does. And eventually, once we start making movies in space, we'll plan to develop, do we need tripods? Do we have to create, do camera sensors deteriorate if exposed in space for a long time? I mean, we have the ones on the ISS, but is there a way to, fix the glare from the sun? A lot of things that don't exist yet. So it's just kind of opening up those questions and what are the right questions to ask when filming in space and on other, terrestrial bodies.
Well, I mean, so Anna, you're no stranger to being in front of the camera. Not only did you work for the Mexican Space Agency, but you also have done some videos, more than a few videos for NASA en Español, and you even did one for NASA here in the U.S. You've done a lot of things like that. So as a communicator of science and talking about space, in particular on your news show, it's something that you're excited to talk about. Can you share a little bit about what that's like to kind of get that out there and what it's, to be in front of a camera and share that with the world?
Your mic is off.
You are muted. Let me unmute you. Oh, nope. You muted them. You muted yourself.
Yeah, I'm sorry. I'm sorry. I think it's super exciting. It's one of the most exciting things to do, not only because you're in front of a camera, but because you get to share your passion and to kind of inject this emotion that we all have with other people that are not maybe feeling the same or are not seeing the space world as we see it. So having the opportunity to talk to millions of people every day and to tell them about what's happening around space is what really moves me every day to be in front of that camera. And I just love to imagine the faces of the people when you're telling them these amazing stories that you know, and these amazing events like the one that we just witnessed minutes ago. So it's very, very exciting. And of course, it would be my dream to do what our other guest is doing, to do it from space. It would be the most amazing thing, because sometimes you tell people about space, but they can't really imagine the whole thing, even though you're showing them pictures or images or films or whatever. But if you could tell the story from the place, I think that would be the ultimate experience.
And so, Lee, you got to train as an astronaut on TV with the one and only Emily Calandrelli. Now, you and I are working on a secret project with some of the other student astronauts that we can't talk about. At least I don't think we can talk about it, so we're not going to talk about it because I don't want her to yell at me.
I have no idea.
Yeah, I don't know, so I'm not going to say anything about it. But you get to do some pretty cool things. Again, you get to train on TV. Well, you get to train and then it went on TV, I should say. You did more than what was out there. But tell us a little bit about, going and doing that, and what I'm sure had to feel like the first step towards a dream, right?
Yeah. So Ron and I actually were both finalists for this thing called the Student Astronaut Contest. It's run by Emily Calandrelli's show Exploration Outer Space. So that was fun. That's how we met, actually. And then Ron came down for our launch, and we were jamming out to Peanut Butter Jelly on a road trip down to Orlando. I live here in Jacksonville, which is not too far off, but
Peanut Butter Jelly.
that was a fun road trip.
It was a terrifying road trip. Lee drives like he's in a rocket.
you gotta manifest. But yeah, I mean, it was, so when I was in Russia with Emily and we went to, it was kind of surreal the whole time. It was like, is this actually happening? Is this, like I was in the Yuri Gagarin Cosmonaut Training Center, riding the centrifuge, wearing a spacesuit that's been to space, getting it fitted onto me, and trying on the oxygen, which feels really nice, by the way. That's very underrated. No one really talks about how good the oxygen feels just rushing around all over the suit. And sitting in the space in the Soyuz trainer and actually figuring out what all these buttons do, especially in Russian, and trying space food, all that stuff, and then sharing it through Emily's show and my YouTube channel. It was surreal. I mean, and it kind of encompassed everything that I've worked my life toward. Making a movie, making videos, educating people about space and science, and then actually going out and experiencing things. And I love that quote by Julius Caesar: "Experience is the greatest teacher." So I always, in my videos, I always kind of push to, go on adventures as an excuse to learn something. So really hands-on learning. And I know myself and a lot of people are not book learners and are not very good when taking tests and stuff like that. So I think visually and, doing hands-on stuff will interest a lot more people in getting into STEM and into, the fields that we love.
So what we're going to do is, one, we've got our president, Janet Ivey, joining us here at the end. She's been on the wonderful Space for Humanity live stream. Well, I'm sorry, the event that they did. It was, if you haven't checked that out, they were doing something. I think it was more of a private show, but they had like Bill Nye, Alyssa Carson. They had tons of great guests too. So we're glad to have you here at the end, Janet. And Chris, before we wrap up and get everybody's final thoughts and do the giveaway, do you have any? And wait, before we do that, I almost forgot. We have another giveaway going on so that way you can get one of the ultra cool MOVA globes. I'm trying not to drop it. Yep. So we're doing that. So all you have to do is you got to go to our Facebook pages at explore.theword.org, and also go to Stardom Space at Stardom Space, and you can find out all the details to win that one. And then there's a second one, which is awesome, that I'm doing on Instagram on Stardom Space. So make sure you join that one too. So we got 2 Mars MOVA globes that you can win today. Lucky you. So,
Hey, Ron. Hey, Lee.
hands-on stuff is everything I'm all about. We should connect because that's the most fun thing that I love to do with all the kids. I hope everybody who's watching enjoyed the magnificent thing. There's not a launch where I don't just cry. And I don't know, to start my day out, with Bill Nye the Science Bill Nye the Science Guy, and then watch the Mars rover like blast off so beautifully and so quickly off that launch pad. I've been up for hours, but what an amazing day. And just everybody keep dreaming. It's like everything as we work together. It's like I feel like this moment elevates humanity as we're kind of proving what we can do when we all work together. Thank you to the thousands of engineers and scientists and artists who dreamed this day and this rover into being, for standing on the shoulders of Viking and all the rovers who have gone before. So I wish everyone a fantastic Martian day out there. I think I'm floating a little bit with that ULA Atlas V rocket. It's pretty fun. It's a pretty exciting day.
One thing I want to mention too is that I want to take an hour off here in a few minutes, and then I am going to start a new live stream that's going to be the official after party. And what I'm really happy about is that 3 of the people on this call today are going to be joining me on that one. So check out Space Foundation 1 at Space Foundation 1 on Facebook and SF Discovery Center. Either one of them you can find on Facebook. You can find us on Twitter and YouTube. Just look up Space Foundation. We're going to talk more at length with Chris, Anna, and Janet. Lee wasn't invited because he's been busy shooting like films and stuff, but he knows that he is allowed to. He's like, yeah, whatever. So Lee, kind of your final thoughts on the launch today as we start to wrap up.
Yeah, I mean, it was super cool. It like leaped off the launch pad. It was unreal. And the fact that, this is kind of a reiteration of Curiosity, and the fact that in 7 months we're going to see, that 7 minutes of terror as it enters the Martian atmosphere. Now we have super advanced cameras on this rover and microphones, so we're going to be able to, in a human way, experience what it's like to descend onto the Martian surface. So that's going to be a really exciting time coming up after this.
And Miss Ana Cristina Olvera, final thoughts for today?
Yeah, well, I think it was super exciting, and having our 3rd launch to Mars this year in a few weeks, it's something to remember. And also, I'm so excited and so glad that we could have it in this year that has been so weird, and that we all need a little bit of excitement. So now we have this to look up for, and all the science that we're going to discover. And I think, perseverance is what we need right now. And we're going to all get out of this, and we're going to continue exploring the universe and being great as human beings.
And Chris, as you give your final thoughts, I'm going to hit the randomizer for all the comments and find out who our giveaway winner is going to be. So, what better way than to finish with the CEO of Explore Mars before we do our big Humans to Mars Summit giveaway?
Absolutely. I think Anna hit it right. Perseverance is what we need. Perseverance is what we got. Successful launch, but with all those other ones. So I think, within this strange year, this has been just a perfect event to help just raise everybody's spirits. And of course, we will be back. We'll be following it the whole way. We'll be doing additional events in February when it's scheduled to land, and the other missions arrive at Mars as well. But we also, as you mentioned, one of the giveaways, of course, will be, I believe, a registration to the Humans to Mars Summit. Normally, we do that live. It's the largest annual conference focused on humans to Mars in the world. Of course, this year we weren't able to do it live. So we'll be doing the virtual Humans to Mars Summit on August 31st to September 3rd. So we hope everybody will join. We have an incredible agenda, coming together. We'll be sending out details soon, but I think it's going to be the best one yet. And I think everybody will want to be part of this event. But thank you to everybody who's come on. Thank you to the entire NASA team, as well as all the international players, as well as the UAE and China. This is a very exciting time, and we all look forward to February when all these spacecraft reach Mars.
And so I want to thank everybody for coming on today. And so the first thing we're going to do is I do want to make sure to go ahead and do the giveaway. Thank you, everybody, for tuning in and checking us out today. So if you are still watching, Christopher Mick, you are the winner of the virtual H2M ticket. So you can get a hold of me at ron@exploremars.org. And honestly, anybody, if you want to get a hold of us and talk about what's going on, I am the communications and social media manager for Explore Mars until I renegotiate with Chris and get a cooler title. Chris, I need a cool name. Can I be like the chief visionary officer? Can I call
whatever you want?
I'm the chief visionary officer.
But you can name yourself whatever, except
just email him and let him know. He's a busy man. But it was wonderful to have you all on and all of our incredible guests from all over, from the industry to some of the wonderful science communicators and people that are out there today, to our president, Janet Ivey. So we appreciate everybody coming on the live stream. Once again, Christopher Mick, you are the winner. Please email me at ron@exploremars and check out the Virtual Humans to Mars Summit. You can find out more on exploremars.org/summit. And don't forget the giveaway. You got to check out the giveaway. So we appreciate everybody coming on the show, watching with us as we hit the 5-hour mark on our stream. We appreciate you all. And, so Janet, Chris, you want to say anything to our audience as we leave?
No, we hope that you'll join us for our virtual Human to Mars Summit. And if you're wanting to get involved and want to know more about how you can support the mission of Humans to Mars and Explore Mars, please reach out. I'm Janet at Explore Mars. Chris, I think and Ron kind of gave you his address. You can always find that in the comments below, but reach out. It's like we are venturing to other worlds, and Perseverance is paving the way today. So, yeah, get in touch with us. We'd love to have you be part of the Explore Mars family and team as we go to Mars as all of humanity.
And one thing that I will mention is that, fingers crossed, we are going to have an in-person landing event in February. That is our goal right now. So as long as Chris get everybody together. Like you're the DC guy, you're the policy guy. Get them together, man. Tighten down.
I will. We'll get on top of this pandemic.
I'm the CEO of Explore Mars.
Well, it was fine for a while, but I've had enough of it. So we'll have our live event in February.
All right, everybody. We'll see you soon, Lee. And thank you so much for coming on and joining us. Bye, everybody.
Thank you.
Thanks,
Bye.
Ron. Hi, guys.